Okay, so I forgot to do the cool transition-y thingy. That's my bad. Give me uno momento. Here, let me get something on just so it's not entirely quiet. Yeah, here, enjoy this for a moment. Okey-dokey. I think I'm ready. There we go. Alright. Today we are grinding out AP stats. I did not mean to remove that. For right now, so let's... I'm gonna get some VLC music going on here. Let's see, not here, not here. Not Friday Night Funkin'. Let's see. Let me find music. Let's see here. Perm. Let's see here. We're gonna ignore the bunch of random songs and I'm just gonna throw in video game OSTs today. Super Mario RPG. Let's do... should I do New Super Mario Bros. Or New Super Mario Bros. Wii? Or should I do newer Super Mario Bros. DS? Let's do newer. Alright. Okay. This should be good. Hopefully it's not too loud. If it is, let me know. Oh, awesome. Oh, that's right. Can't see chat. Are you sure? Let's see. I hear echo. No, come back! Come back! Okay. Okay, it's a little low. Okie dokie. Now we're grinding AP stats. So for first things first, we're going to do. I missed some work on Monday because that was the AP Bio test, and you know we were, AP Bio. You know we were grinding for that. so first things first. Let's do our missing work. Only missing, and then I have a valid excuse is that I was busy. What do you know? My stats teacher literally just posted an update. Let's see. Thank you. Okay, so yeah, grades are final. So, but except for additional stuff, and then so I need to turn in the missing work, and then I'm going to do the extra credit. So let's see. Okay, so here are the results of the FRQs. So let's see. Describe a distribution. Box plot, compare distributions, segmented bar graph, interpreting, compare distributions, convenience sample, probability, joint probability, define binomial, okay. Matched pairs, the mean difference, the difference in means, that's 2 sample. Describe relationship, abnormal distribution. And just so you know, the investigative task is something you've never learned before, but if you use the question and the tools you know, then you'll be able to solve it. So that's what's going on here. Let's see. Always include context, don't leave any blank. Yeah. 2 variable data. So this is the predictions for this year. Binomial mean, standard deviation, we're given that, so it's on your note sheet. Okay, final exam questions and reflections. Let me see what I got. Oh, no, the final exam isn't here. Can I do this? I guess I did. Up and then do the free response. Alright, take a look-see here. Ooh, okay. Okay, we'll take that. This is good. But it's okay. We're gonna look past that, okay? But for right now, Thank you. I forgot about that. There we go. Okay. Thank you, Dad. Let's work on what I missed. Let's see here. This is interpretations review. Is that the practice? Let's see, practice. Next class, we will practice the investigative task. See, actually, we didn't do that because there's no school today. But, let's do this first. Alright, let me log in real quick. Shoot. let's do this first, because at the very least I know I have to do this. All the statistics involves copy. This one was too soon. Moving on. I just had a seizure. This is good. I could be happy. We want to be sure tat we know autos computations. I don't know what this is supposed to say. Can lead us to make conclusions. In this activity, you will review how to draw conclusions based on probability calculations. Copy writ to college board. AP is a registered trademark to college board, which was not involved in the production of and does not endorse this. I think I know what's going on. I have a textbook right here. There we go. Okay. That was going to be really funny. Those involves what we want to be sure that we know how to do these compositions, conclusions. There we go. Increase morale among employees. Suppose that receives a gift for an entire 52-week year. This back to how strong the selection process was actually random. Let's see. Company began a program in which one employee is randomly selected each week to receive a gift card. Each of the there we go. Each of the company's 200 employees is equally likely. Oh, never receives a gift card. See that many gift cards. Let's see. So, if expected, so we have observed. Let's think about how we want to solve this problem. Hold on, because we're dealing with hard stuff. Let's see. We're thinking. Suppose that Agatha, an employee at the company, never receives a gift. Okay, so we know that she's below the expected value. Let's see. Okay, let's figure out the probability. Actually, what we'll do is we'll do a split view with Desmos. Graphic. So the probability that an employee never receives a gift card at a week is this. And then what we'll do is not an option. Really? Are you serious? Must not. Okay. But so let's see. We'll take this probability and we'll raise it to how many weeks are we at? 52. Oh, I guess the probability that an employee receives. I'm using the wrong number here. So basically, if each employee has an equal amount, so this is the probability an employee doesn't receive one, right? Because, and then let's see. That seems relatively high. And then so actually what we can confirm is this is literally what we just calculated, because 1 minus the probability. So no, she does not, because the oh my god, because the probability for this to happen by is where's the approximate? I think it's this one. No, it's not. Okay, hold on. Oh, 247. All right. There we go. Approximately, what, 77%? Because the probability for this to happen, let's say to occur by chance is significantly high. So the probability or expected value. Okay, well, let's explain them then. This occurring. Okay, I don't care about passive voice. That's not important. There we go. Does not provide. In fact, she would not. But she is much more likely to not get a gift birth than she is to win one. Also, an employee receiving 0 is not unusual because the expected value is close to 0. Helpful tip number 1. When using a probability to justify a decision, be sure to state if the probability you are using is large, small, or likely, unlikely. Alright, we'll do that from now on. Okay. Interpreting a confidence interval from the mean. Let's see. Oh, my neck. Environmental group conducted a study where there are crows in a certain region where ingesting food containing healthy levels of lead. Biology was classified lead's greater than 0.6. Okay. Sample mean. Write a sentence that interprets this interval. Okay. We are 95% confident that the true mean, let's see, lead levels in crows. In this certain region. What is it? 4.416. 5.384 point. 384. In this? No, certain using the word. Level. I was wondering. Reference the population parameter, the mean. I stated, and then I referenced the population of all crows. In the area, yes. Yes, all crows in this region. There. Alright. Oh, helpful tip number 2. When you write your interpretation, be sure to reference the population. If you said these crows, you would not. You would have been talking about the sample. Okay. I did that. Write a sentence that interprets this interval. We are 90% confident that the true confident that the true proportion of all customers who with water filled up their cup with a soft drink. And the interval 1.883, 0.3867. That's not bad. Population parameter 95, reference the population of all customers. Yes. Yeah, this is another way to write it. Be careful of road tense. If you use past tense, it means you refer to the sample. Really? Fill up. Okay. I should probably re-answer this one then. Let's see. What's that one? Here. Meaning that just sad you didn't get free money, which is fine. I wouldn't either. I would be too. Right. Does the confidence interval provide that the program generates discount with the probability of 2? Let's see. So, let's see. So this proportion that will receive a discount in the long run. I think so, because the true proportion of bills that discount in the all there, which is continuing. We can do this in our head. 0.09 0.21 I love this song, The Pandemic. It does contain the value 0.2. Calculate for the upper low numbers for the interval. Compare the endpoints in the interval to make a decision. Oh, are we saying like decisive conclusion? is teaching me to be stingy. Remember that a confidence interval gives a range of all values are likely. Okay. So the data provides statistical evidence. Because this is let's see, it's two samples but one variable, so it's a chi-square test of homogeneity. Saying this homogeneity. Guys, I'm thinking. I'm definitely not getting distracted by Jack Black. Alright. So, let's see here. Since 0.012 is less than 0.05, we reject the H naught and have significant evidence that let's see. Our H naught would be that there okay, we're thinking. Let's see. So we know for goodness of fit. Okay, hold on, let me pull up my guide. Might be wondering what guide? This one. Any day now. There we go. Okay. So as you can see, what goodness of fit is checking. Okay, so goodness of fit is the claim is true, claim is false. Homogeneity, which is two samples, one variable, is that the variable is the same, and that this one is the variable is different. It's asking for association, which I would assume means they're talking about independence, but like it's not independence because there's two variables and only one sample. So we're just gonna say that there is no association. If I could find the, here we go, okay. Wait a second. This is one sample. It's tricking you. The two variables are their gender and age group. So actually, it is independence, and we're saying that they are not independent. Between the age group and gender and the diagnosis of schizophrenia. Yes! It didn't give us an alpha level, so we're saying 0.05. That decision included context. It did. Because the p-value is, just say less than. We reject the null hypothesis included by strong evidence that there is an association between age group and gender in the diagnosis of schizophrenia. Notice be sure to link your conclusion. Reject the null or fairly reject the null to an appropriate alpha level. Okay, you are doing a test significance of the p-values too high. Since we would not accept, we would reject the null hypothesis, or if we would fail to reject. No? Okay, let's see. Oh, I get it. Accept and fail to reject is not the same thing. We would not reject the null hypothesis. Yeah, there we go. Okay. I'm finished. It took 30 minutes. I'm a little slow. You can load whenever you're ready. Alright, sweet. What the freak is this? Who is this? Is this me? That is not me. Alright, well this is done. So now Let's see. So what are the other assignments we have to do? Final exam questions and reflections. Yeah, interpretation review. I think that's this one. Desmos practice. Just did this one. Practice FRQ in groups. Okay. So there wasn't an assignment for this. And then we didn't even turn it in last time. This is not a good outcome. Correct. Okay. We could do it. I think I'd rather do the extra credit since that's more points. So if we have time, we'll go back to it. But for now, we need to do this. Okie dokie. Let's see, what are we working with here? After a physical education class does the mile run, the teacher records the heart rate and find the mean of that. Interpret the standard deviation in the context of the problem. On average, we can expect each
What y'all know about this right here? What y'all know about that Nintendo?
Why is it called Nice Star? What's this song? This one. This one's fire. I have no idea what the title means, by the way. So expect to vary from the mean. Sorry, vary from the mean. Can you read that? 5.3 ppm by 7.2 ppm. There. This is the score I want. Can you move out of the? How do I get rid of this? Is there a setting? I get it now. Oh, sweet. I'm writing this gonna be shut down, so it doesn't matter. There we go. Accessibility. No, it's not Comic Sans. This is so sad. $68 active sessions? Where? Oh, hey. Okay, so he doesn't actually have a score, but one's score is 1.2 standard deviations above the mean 5K marathon time. I noticed you restricted yourself there. For a biology, how much is this? 2 pages, not bad. From a biology project, Elise? No, this. Oh, it's because I spelled pronouns. Ebizy. Okay. No way this song is called this. Fluff Fluff. There's no way. Let's see. Interpret the correlation. that good? Or do I need more? Yeah, that's good. Moderately strong, positive, and linear. Okay, because when you interpret those, you're able to interpret the R value. Sorry, stretching. Yeah, Cowboy Bebop. The weather changes every month. Fibbage and Quiplash. Alright, let's see. Remaining height, so interpret the slope. For every one increase of for every one increase of we can expect the height of the candle to decrease by 0.37 inches. Okie dokie. Y-intercept. We can expect or predict it. Let's say we expect the candle to be 0 hours there to be 9.06 inches tall. Okie dokie. Over the course, okay. Oh, well, Nancy, I need to stand. It's really cold outside, apparently. Over the course of the semester, Brian has built a model to predict a score of a test based on blah blah blah. In his most recent test, Brian studied for 3 hours, and the prediction has a residual. Okay, so the residual, this one. Let's see. So Brian's actual score on his test differed from the expected score by different. Okay, so his actual score was, because to calculate residuals, you do the actual value minus your expected value, and then since it's negative, that means okay. Sorry, but this guy. I do not like this guy singing.
Attack is weak point.
For massive damage. Okay, let's see here. Ryan's actual score on his test was what was it? 5.36 points below the expected score predicted by his LSRL. When studying for 3 hours. This actually should go later, so what we're gonna do. Oh, freed. Okay, there we go. Was 5 points. was 5.36 points below the expected score predicted by his host. Hello? Hold on, we're clipping this. It's a moment in history. My Grammarly is an idiot. Bray Iron. Are you so what if someone was named Bray Iron? Brain. Oh, brain. Sorry. Okay. Well, we're moving on. Actually, you know what? I will return momentarily. I'm gonna go do something. I'll be right back.
dances with me. It is all of the things that I wanted to be. I have a magic rock and it teaches me. I have a magic rock and your jealousy. It's magic, it's wicked, it's colorful, so good. It's super, it's so cool. It makes me look like a fool. It's magic, it's wicked, it's colorful, so good. It's super, it's so cool. It makes me look like a fool. Yes, you look kinda sad. Give me just a moment and I'll make you glad. If you don't want any help, just you say. You know I've got a PhD in brightening days. You may not see what I see in you, but let me tell you what I see is true. My eyesight's fine and I'm rather in my mind. I've got you in my thoughts all the time. If I could take your hand and kiss you, if I could hold you close and love you, the summer breeze or the winter frost, not a season's moment will be lost. 'Cause sadness is just a waste of your days. I could cheer you up in a million ways. If I could take your hand and kiss you, I kiss you. If I could hold you close and love you.
Apologies for that lengthy delay. We are back. So actually, here's what we're gonna do. Interesting. Go to Tools, Scripts. Clock source. Oh no, that's fine. Oh, that's cool. Look at that. It makes a clock. Look how this is now. I should look into OBS scripts. That would be really cool. We're learning. Okay, so I want. There you go, stopwatch is a better word. Not a countdown timer. Not countdown. You may advance the timer. Gimme. Save it there. I don't know who you think I am, but I own this computer. Let's see, where is... I give you permission. Okie dokie. Advanced timer. So we're gonna do count up. Okay, sweet. Now we're gonna change. So see, we can put our own font. I've been absolutely melting this font just because I think it looks so awesome. Let's see, been gone since. Like been gone for. There we go. See, and then so it centers E2. Now we'll group them. So if I deactivate this, then yeah, it should reset the timer. Yeah, there we go. Okie dokie. All right, let's get back into statistics. From a variety of vehicles. Okay, sorry, I'm just checking my audio. Pressure applied. Okay, for this model, so R squared. So this means that I believe it's 63.2% of the variance in the data. Let me double check. Yes, of the variance in the stopping distance. Variance in stopping distance at 60 miles per hour can be attributed, who came up with this? By the LSRL of I know it says linear relationship here, but you should be able to use the other thingy. Ignore what that word means. I think it's a good song. A new coffee shop records the number of daily transactions for a random sample of 30 days. Okay, my hair's not fully dry. Hold on, I'll think about this one. Okay, let's try it. Alright. New coffee shop. We are 99% confident that the true number of transactions per day is in Statsmatic is interested in sponsoring the Grand Rapid AAA base team. Type 1 error. So, as a reminder, a type 1 error is when you let's see, so that's true. It's when you reject the null hypothesis, even though, or it's when you, reject the null hypothesis, but the null hypothesis was actually true. And here, I'll pull up, do not leave. The other study things I made in collaboration with a friend. So you can see here. So you reject the null hypothesis, but the null hypothesis is true. It's a type 1. And if you fail to reject the null hypothesis, but the alternative is true, then that's a type 2 error. And then the probability of correctly rejecting the null hypothesis is the power. And then there's additional information right here, blah, blah, blah. So this means that we reject the null even though the null is true. We would determine that sponsoring a team that what are my parents doing? Alright, and then we would Caps games last season, thus not I think that's good. And then let's see. Blah 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 blah. It's somewhere, yeah, right here. See. That did actually. Okay. Excuse me. Sample, let a sample mean of this many people. After conducting a significance, interpret the p-value. If we were to determine that because if we're talking about mean, then that means, get it, that means that the, let me double check here. And then it's a t-test. Yeah, so we're just saying that it's the claim, which is this, so. The probability of getting hold on, how do they want us to do this? Yes. They don't give us an H naught. That the H naught was true. The probably then is 2.31%. There we go. Okie dokie. That's the assignment done. Yeah, that's it. Okay. Ultimate interpretations practice as we skip over Unit 6, Unit 6, and Unit 7. Okay. Apologies. I may have lost my cool. It's missing. I need to send an email that I turn this in. Which I'll probably do that once we do all of the other stuff. Okay, so now that this is done, now it's time for all the extra credit. I believe there's 8 of them. Okay, 8 separate reviews. Videos are available to fill each video with a handout that is downloadable. Didn't get to a place where you can write on. Bottom of the note sheet. For your final. A little late, but whatever, that's okay. No senior grades will be accepted after. Okay. Let's grind this. Sorry for the annoying second folder. You must access the videos from a district account. For the best, I was reading that. For the best benefit, you need to download the files. You absolutely must resolve the file at least 2 seconds. This is where it comes from. Okay. So I think I see how this works. Okay. These are funny videos. But yeah, let's do it. These are not that long. If I need to add notes, we'll just add another page. You did not need to do all that to add a page. I just changed it to white because I think it looks better, but I want it to be an outline. Let's see. Actually, that did nothing. Whatever. Middle school science project. Jalen measured the pH of 25 vinegar products. The summary statistic for the values of pH are shown in the following computer output. Based on which of the following statements is true? Okay. You know what this means. We're gonna have to calculate. Okay, so for our lower, we're going to do, it's going to be 1.5, or it's going to be 2.23 minus 1.5, and the IQR is 0.55, which equals, let me get my trusty calculator.
Attack is weak point for massive damage. Attack is weak point for massive damage. Attack is weak point for massive damage. Giant enemy grab. Attack is weak point for massive damage. Attack is weak point for massive damage. Attack is weak point for massive damage. Giant enemy grab. Attack is weak point for massive damage. Attack is weak point for massive damage. Attack is weak point for massive damage.
All right.
Giant enemy grab.
So, giant enemy crab. Attack its weak point for massive damage. Brum, ba, bum, ba, bum, brum, bum, 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 bum. Okay. So outliers are 1.405. Now for upper, it's going to be 2.78 plus 1.5, 0.0555, which equals excuse me. $3.605. This is not an outlier. 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 So it must be E. The tail length of Siberian. How many problems are these? How long are the videos? I really need to clean this up. Scripts. Actually, let's see here. I'm looking at all these scripts. You guys can see. Let's do rating. Yeah, descending. What is this? Okay. La, 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 la. yeah, this is the thumbnail. What the freak? Battle for Dream Island. What the? Popeye's Wing Arena. What are these photos for, bro? That's Cyber. Still working on that. Okie dokie. Sorry for getting distracted. There are 5 problems total. I was looking to see how long it is.
Hello, AP Stats.
13! Okay. We're gonna watch a little quicker. The tail length of Siberian tigers is approximately normally distributed. What's the following best interpretation? Okay, so if I need to show my work, n, so n equals 0.85, move, 0.13, and then so we can do normal CF. Actually, we can just do z-score equals let's see, it's going to be your value. Okay, so in this case 0.8 minus 0.85 divided by your standard deviation 0.13, which equals, I remember, approximately equals, let me put in my calculator, minus 0.85 divided by 0.13, negative 0.38, and then so the what? We're talking about the interpretation of the z-scores. It's not gonna be this, it's not gonna be this. It's not probability, and it's going to be below the mean because it's negative. Suppose a excuse me. Suppose a hypothesis test will be used to investigate whether the what the freak is this, bro? Also, I haven't heard a single new supermarket road. Hold on. Where is mine new Super Mario Bros? Where? Did I not put it in? I guess I didn't. No. Where is it? Oh, I like this one. Okay. Let's get back on track. Okay. Suppose the if the significance level is changed to 0.1 and the power test is computed. Let's see. Well, so think of it like this. So the power is the probability of you correctly rejecting the null. And then so if you decrease the alpha level, your percentage of correctly doing it decreases. So the power would decrease. Well, actually, no. The power, you said correctly in rejecting the null. Yeah, so it would decrease. And then, so we're thinking of the type 1 error. The type 1 error is just the significance level, so it would also decrease. Because think of it. Type 1 error is where you reject the null, but it's where you reject the null, but the null is correct. Yeah, I'm pretty sure. If not, the video will talk. If I need to show my work, 1 minus p. There, okay. An agriculturist, okay. So random sample, the mean. So let's see. 25 if it's the mean. And degrees of freedom will be 24. Was it 90? Yeah. So 1 point, so it's gonna be 42 plus slash minus 1.711 times yeah, 3.6 divided by square root of 25, which is just 5. And so 1.711 times, what is it? 3.6 square root of 25. I got this one. Large company operated, assuming the rate of absenteeism is the same for each day of the week. Okay, so absentee, so it's same for each day of the week. We are testing homogeneity, sameness, sameness, same, freaky. Okay, there we go. Sorry, get a little fun. We're gonna sort this by album. And we're getting rid of all the Harris Hellers that you got one of them. There are some Harris Hellers that are just so beautiful like this. And then I love this one. If you don't know who Harris Heller is, by the way, this guy, absolute goat, gives you streaming tips. And then yeah, see, Stream Beats. It is DMCA free music, and then they're good music. I guess he quit sugar for 30 days and then 100 more. Reformed Red Bull addict. Wait, where did your streaming stuff go? What? Hold on. We were getting in the rabbit hole. Who is Senpai? Are you Harris Heller? Oh, or is this the channel I was thinking of? This is the channel I was thinking of. Okay, but it is Harris Heller. Okay, so he does still do this thing. I guess he also has a personal channel. Okie dokie. But this guy, incredible, helped me, learn some of the ropes of OBS. Anyways, let's not get distracted. Okay, appropriate chi-square formula. What is the contribution of Monday absences? Okay, so the total amount of days is 150. So over 5 days, so our observed minus our expected divided by our expected. So that comes out to be, so 100 divided by 30. Okay, now it's time for the video. Yay.
Students, and welcome to AP Daily Practice Sessions, your absolute best way to prepare for the AP Stats exam. My name is Luke Wilcox, and I'm an AP Stats teacher at East Kentwood High School, Go Falcons, where I have taught AP Stats for almost 20 years now. Now in this first session, I'm going to take you through 5 multiple choice questions that have been carefully selected to be ones that are most likely to occur on the AP exam. Now I highly suggest that you download these questions first and try them on paper before coming to the video to look at the solutions. So let's go ahead and jump right in. Number 1, for a middle school science project, Jalen measured the pH of 25 vinegar products. The summary statistics for the values of the pH are shown in the following computer output. So we see the variable is pH, the sample size is 25, the mean of 2.50, the median of 2.49, standard deviation of 0.26, a minimum of 2.11, a maximum of 2.93, a Q1 of 2.23.
You know what I actually realized I think might be a great idea for notes? Instead of boringly typing them, right? I'm gonna pull out my drawing pad. Hold on, let me show you. Scooch over. It's Mama's turn. Or Dad. But look here. This is a wireless one from Wacom. We got it. I got it at a thrift store for like $10. And then we also have this one. I'm realizing now this is about the same size, but I've used this one for a long time. This one's wired, so I guess sometimes it would be better, but this one suits my purpose as well. So it's nice to have options. And maybe I'll get into OSU, but I'm really bad at OSU. Really bad at OSU. All right. Story time over. Get me off of here! Ah! All right. Who is Buki? Anyways. Alright, we're gonna take notes.
And a Q3 of 2.78. Now here comes the question. Based on the 1.5 IQR rule for outliers, which of the following statements is true? Now answer choice A says that 2.11 is an outlier and there are no other outliers. Answer choice B says that 2.93 is an outlier and there are no other outliers. Answer choice C says that 2.11 is an outlier and there could be other values. Answer choice D says 2.93 is an outlier and there could be others. And answer choice E says that there are no pH values that could be identified as outliers. Now you'll notice in all the answer choices here, this is all about outliers, and so we're going to have to do some work to figure out if we have some outliers. Now a quick review of the 1.5 IQR rule. So here's what the rule says. You could possibly have an outlier that I call way too low or way too high. So we're going to start with outliers that are way too low. And what makes them way too low is that they're less than Q1 minus 1.5 times the IQR. So we have to calculate what this value is. So we're going to grab the Q1 and the Q3 from the summary statistics, plug those into the formula here, and we see that we get an outlier if it's less than 1.405. Now looking at the summary statistics, we have a minimum value of 2.11, and that is not less than 1.405, so we do not have any outliers that are way too low. Now on the other side, let's look for outliers that are way too high, and that means they're greater than Q3 plus 1.5 times the IQR. Now once again, we're going to have to grab some values from the summary statistics here and plug those into the formula, and we see that an outlier is way too high if it's greater than 3.605. Now looking at the summary statistics, the maximum value in the data set is 2.93, which is not greater than 3.605, which means we don't have an outlier that's way too high. So no outliers that are way too low, no outliers that are way too high, there are no outliers overall in the data set. So if we go back to our answer choices here, the first 4 all say that there is an outlier, and we know that's not the case, which leaves us with the correct answer here is answer choice E. There are no pH values that can be identified as outliers. All right, question 2. The tail length of Siberian tigers is approximately normally distributed with a mean of 0.85 meter and a standard deviation of 0.13. Which of the following is the best interpretation of the Z-score for a particular Siberian tiger with a tail length of 0.8 meters? Now here's our answer choices. Answer choice A says the tiger's tail length is approximately 0.38 standard deviations below the mean. Answer choice B says the same thing but above the mean. Answer choice C says the tiger has an approximate 0.38 probability of having a tail length of 0.8 meter. Answer choice D says the tiger's tail length is approximately 0.0065 meter greater than the standard deviation. And answer choice E says the tiger's tail length is approximately 0.05 meter below the mean. Now this question is all about Z-score, so we're going to have to calculate
When
a Z-score.
did I do that?
And the formula for that is x minus the mean divided by the standard deviation. So let's find those values in the prompt.
Okay. Yeah, whatever.
Okay, the x value is the tail length of 0.8 meters. The mean is given to us as 0.85, and the standard deviation is given as 0.13.
Hold on. I'm hearing things.
So go ahead and plug those into the formula. Now in the numerator there, we're getting a value of negative 0.05, which is telling us that this Siberian tiger tail length is 0.05 meter below the mean. But then we're dividing that by the standard deviation in order to give us the Z-score, which is going to tell us how many standard deviations away from the mean we are here. So looking at the answer choices here, answer choice E looks like a good answer choice and is in fact a true statement, right? It is true that the tiger's tail length is approximately 0.05 meter below the mean, but the question is asking for an interpretation of the z-score, and 0.05 is not the z-score, so that's the incorrect response. Now, looking at the other answer choices, A and B are the only ones which sound like an interpretation of a z-score. And the thing about answer choice B is it's saying that it's above the mean, which would be a positive z-score. Okay, we do not have a positive z-score here, so that answer is incorrect. And that leaves us with the correct answer choice here. Answer choice A, the tiger's tail length is
Let's double
approximately
check.
0.38 standard deviations below the mean.
Yeah.
All right, here we go. Question 3. Suppose a hypothesis test will be used to investigate whether the proportion of United States adults who have been a victim of cybercrimes, such as identity theft, is greater than 0.25. Suppose that the hypothesis test is conducted using a significance level of 0.05, and the power of the test is determined for a specific alternative value using significance level of 0.05. If the significance level of the hypothesis test is changed to 0.01, and the power of the test is computed for the same alternative value using a
This one
significance
I
level
might
of
get
0.01,
wrong.
which of the following best
This is the
describes
one
the
I'm least
changes to the
confident in,
probability
so
of a
we'll
type
see
1
how I
error
do.
and the power of the test? Now, answer choice A says type 1 error decreases.
Oh, you know
power
what? You're
stays the
probably
same.
hearing echo.
Answer-
Hold on. So actually, no.
Choice B says type 1 error decreases, power increases. Answer choice C, the type 1 error decreases, and then the power decreases. Answer choice D, type 1 increases, power increases. And answer choice E, type 1 increases, and the power decreases. Now, we know that we're moving from a significance level of 0.05 to a significance level of 0.01. We want to know what's happening to the type 1 error and the power. Now, a quick review about the errors and the power, which is summarized in this table. The type 1 error is when the null hypothesis is true, and we incorrectly
Fine,
reject.
I'll write out the table. So we'll say and then we have reject, and then we have fail to reject. There.
The null hypothesis. You can also see that power is when the alternative is true, and we make the correct decision to reject the null. Now, here's some other things you need to know. The probability of a type 1 error is just the alpha with a significance level, while the probability of a type 2 error can be found by 1 minus the power. Now, there are 4 ways that you can increase.
So either way, it's correct. Type 2. So, I wrote type 2. Oopsies. Type 1 equals alpha. The probability of type 2 equals 1 minus power. Let's stop going downward. Let's expand vertically. So increase power by okay.
The power of a significance test. You can increase the sample size, increase alpha, decrease the standard error, or if the true value is farther from the null. Now remember, in this question, we are taking the significance level and decreasing it from 0.05 to 0.01. Well, that's easy for the type 1 error. If we're decreasing the alpha, then that's also going to decrease the probability of a type 1 error. Now, when it comes to power, we know that increasing alpha increases the power. So in reverse, if we decrease the alpha, that's also going to decrease the power. So we see the type 1 error decreasing as well as the power decreasing. So when we go back to our answer choices here, the first 3 say decrease for type 1 error. The answer choices D and E say increase. We know that's incorrect. And when we're looking at the 3 that are left here, the one that matches is answer choice C, which says that the type 1 error would decrease and the power would also.
Okay, we're cooking.
All right, question 4. An agriculturalist wants to estimate the average time from germination to ripe fruit for a new type of seedless strawberry. From a random sample of 25 seedless strawberries of the new type, the mean time from germination to ripe fruit is 42.1 days with a standard deviation of 3.6 days. Assume all conditions for inference were met. Which of the following is a 90% confidence interval for the mean time from germination to ripe fruit for the new type of seedless strawberry? So answer A says 42 plus or minus 6.16. B says 42.1 plus or minus 1.49. C is 42.1 plus or minus 1.23. D is 42.1 plus or minus 1.18. And E is 42.1 plus or minus 0.25. So we need to come up with a confidence interval here. And because we're trying to estimate a mean, this is what's called a one sample t interval for mu. Now the formula that you can use to calculate any confidence interval is the statistic plus or minus the critical value times the standard error of the statistic. Now on the formula sheet for the AP exam, you can look up the standard error formula there, and we're going to get a specific formula of x bar plus or minus t star times.
I know it! Okay. It's not T sample, it's going to be a 1 sample t int. So I'm just gonna do x bar plus or minus critical value of s over root n, which is what I did.
S over the square root of n. So now we just need to figure out what values to plug in. Well, the mean you can see right in the prompt is 42.1, that's our x bar. The standard deviation is given there, that's s. And then the sample size of 25, that's our n value. Now what we don't know yet is the t star value, the critical value. And in order to get that, we need to go to table B. And for table B, we need to know our degrees of freedom, which is given by n minus 1, where n is the sample size, which we knew is 25. So that gives us degrees of freedom 24. So we locate that row. Now, we also know that we want a confidence level of 90%, and that's going to lead us to our t star value of 1.7.
We're cooking.
So now we go back and we plug that in for our t star value, do the calculation, and we end up with 42.1 plus or minus 1.23. And that is answer choice C is the correct answer there.
Yes.
All right, last question. Here we go. A large company has operated assuming that the rate of absenteeism is the same for each day of the week. The new human resources director of the company claims that the assumption is false and that the rate of absenteeism is different for some days of the week as compared to others. To test the claim, a random sample of 150 absences was recorded, and the day of the week on which the absence occurred was recorded. The counts are shown in the following table. So we have a table with the number of absences for Monday, which is 40, Tuesday, which is 27, Wednesday of 21, Thursday 34, and Friday 28. The appropriate chi-square test will be performed to test the claim. What is the contribution of the Monday absences to the calculation of the chi-square test statistic? Answer choice A says 0.333, B is 2.500, C is 3.000, D is 3.333, and E is 10.000. Now we can get the formula for the chi-square test statistic right from the formula sheet on the AP exam, and you'll see as part of this formula we need to know what our expected values are. So to calculate our expected values, we have to make note that the assumption is that the rate of absenteeism is the same for each day of the week. And because we took a sample of 150 absences, and we want those to be equally distributed between the 5 days, that would be 30 for each one of the 5 days. That's our expected number. Now remember, we are only looking for the contribution that comes from Monday. So Monday has an observed value of 40 and an expected value of 30. So we go ahead and plug that into the formula, which gives us a chi-square component of 3.333. So the correct answer here is answer choice D. So thank you so much for joining me in session 1 here. Remember, there are 8 sessions total in this series, and you're going to want to make sure that we catch all of them. So I certainly hope to see you in session 2, where we're going to talk about multiple choice for collecting data and probability. Thanks so much for joining me.
2 sentences of what you thought was the most important thing. I think you used most. Okay, so we'll do 1 sentence for each of those. I thought, we're going to try to sound genuine here. I thought that the most important thing that came from this video was a good reminder about the types of errors, specifically how power and type 2 errors relate to each other. On this video, I will most likely maintain the problem-solving strategies demonstrated by the
Your absolute best way to prepare for the AP Stats exam. My name is Luke Wilcox.
This helps, because then it shows, I remembered his name, even though I didn't remember his name, but yeah. Runbow Road, you spelled rainbow wrong. How the frick did the views go down by 1? Not the current viewers, like the total amount of views. Was there an error for Jim? Okay. I will most likely maintain the problem-solving strategy, or maintain and adopt Mr. Wilcox throughout the video. Okay. That's the first one done. Me head itch. Alright, that's the first one. Okay, now we're going to do number 2. Not like, yeah, There are only, if we play our cards right, I might be able to fit all my notes on this page. Okay, so for now. Yeah, even reduced to the corner.
Hello, AP Stats students.
Hello. You're getting put on. Whatever. Alright. A large online retailer places packed, ready to be shipped boxes on a line on a conveyor belt. A sample of boxes will be used to estimate the mean weight. Okay. Generate a random integer from 1 to 20. Use the integer selected initial box. Ah, see? You have an initial box and then every nth box. So this is going to be systematic. An experiment was conducted to investigate whether submersion in cold weather causes a lower heart rate. Okay. So what is it missing? 50 volunteers. It's missing random assignment. Does it need replication? It did compare 2 treatment groups, but they weren't first of all, they weren't randomly selected. We're gonna let him explain, and I'm just gonna say 2 and 3. I don't know if they would throw in a red herring, but they actually, honestly, they probably would. The probability that a particular an electrical system, the system will function successfully. That's it's going to be a 0.75 cubed, which equals 27 over 64. The driving route between a student's home and the student's high school has 2 traffic lights. Distribution of total time spent driving has a mean 15 minutes and a standard deviation of 1 minute. We don't know if it's normal. Oh, the total travel time. Okay, when combining 2 proportions, I believe it's on the formula sheet. Yeah, it's right here, see? Oh, that's subtracting. Freak! Okay. I'm pretty sure, okay, so for the means, you can just add them. For the standard deviation, though, I'm pretty sure you can't just add them. I'm pretty sure it's going to be like square root, and that's going to be like 1 squared plus 0.25 squared. And then that's going to be, let's see, so the square root of 1 plus 0.25 squared is 1.03. So it's probably this one, but I could be wrong. Sorry. National newspaper reported that 40% of high school students engaged in community service activities. The school administrator wondered what the proportion. Okay, what is the following correct interpretation? So first we're assuming, it's not a probability. Or more extreme. That 40% or less. It's this, because so if it's the null, then the probability of observing our value or less or more extreme is the p-value, so it's a D. All right.
And welcome to AP Daily Practice Sessions, the absolute best way to prepare for the AP Statistics exam. My name is Luke Wilcox, and I'm an AP Stats teacher at East Campus High School, where I've taught AP Stats for almost 20 years. Now, in this session, I'm going to take you through 5 multiple-choice questions, specifically on the topics of collecting data and probability. Now, I highly suggest that you download these first and try them on paper, then come back here to the video to view the solutions. So let's just go ahead and jump right in. So number 1, a large online retailer places packed and ready to be shipped boxes in a line on a conveyor belt. A sample of boxes will be used to estimate the mean weight of boxes shipped on a given day. One proposed method for selecting the sample is as follows. Generate a random integer from 1 to 20. Use that integer to select an initial box from the first 20 boxes in the line on the conveyor belt. Select every 25th box that follows the initial box on the conveyor belt for the rest of the day. Which of the following best describes the proposed sampling method? So answer choice A says stratified random sample, stratified by time of day. B says cluster sample with times of day as the clusters. C says cluster sample with box weights as clusters. D says systematic random sample, and E says convenient sample. So lots of different sampling methods that we see in the answer choices here. So let's just jump back for a moment and do a quick review of each one of these types of sampling. Now, the first one is the stratified random sample. In here, you're going to divide the whole population into homogeneous groups. And when I say homogeneous, I mean that within the group, individuals are similar. Then you're going to just select a random sample from each one of those groups. Now, a cluster sample, you're also going to divide the
Okay, so stratified here. So divide pop into, I know what a strata is. I don't know how to spell it apparently. Strata. SRS from each strata, right? And then so now we have cluster, which is similar. So you divide pop into strata, but then you
population into groups, but this time they are heterogeneous, meaning individuals are different within each group. Then you're going to select a random sample of clusters, and you're going to sample every individual for the selected clusters. Now, a systematic random.
Okay, into, we'll just say homo, and then hetero. SRS of full cluster. So actually I got this wrong. Apologies. To cluster. Then systematic. Well, let's go horizontal. Start.
Sample. For this one, you're going to select a random starting point, and then you're going to use a fixed periodic interval in order to select the others. And finally, the convenience sample. This is where we collect data from individuals that are easy to access. And very important here, it does not.
Yeah, there we go. So select. Every nth person. And then we have convenience. Easy to. You can't read that. Easy to access. Individuals. No SRS there.
25 youngest by the population into groups. Random starts to access. And very important here, it does not use any type of random sampling. So now let's go back to our answer choices here. And I think we have some clues in the prompt for this one here. So first, it says that there is a random integer, and that will be the initial box. Now, to me, that sounds like a random starting point. And then we're going to select every 25th box. To me, that sounds like a fixed periodic interval. So what we are describing here is a systematic random sample. So answer choice D is the correct answer here. All right, question 2. An experiment was conducted to investigate whether submersion in cold water causes a lower heart rate. The experiment used 50 volunteers. The 25 youngest volunteers had their heart rate measured while holding their breath for 30 seconds with their face submerged in cold water. The 25 oldest volunteers had their heart rate measured while holding their breath for 30 seconds with their face not submerged in cold water. The mean heart rate for the volunteers who had their face submerged in cold water was lower than the mean heart rate for volunteers who did not have their face submerged in cold water. Which of the following elements of a well-designed experiment is missing? Element 1, comparison of at least 2 treatment groups. Element 2, random assignment of treatments to experimental units. And element 3, replication. Now here's our answer choices. A is 1 only, B is 2 only, C is 1 and 2 only, D is 2 and 3 only, and E is 1, 2, and 3. So let's look at each one of these elements individually. Starting with the first one, comparison of at least 2 treatment groups. Well, you'll notice here that we did have 2 treatments. The one treatment was what they were submerged in cold water, and the other treatment was that they were not submerged in cold water. So we definitely have comparison of at least 2 treatment groups. Now element 2 says random assignment of treatments. Now looking here, we have the 25 youngest volunteers going to the first treatment, the 25 oldest volunteers going to the other treatment. This is definitely not random assignment. They were assigned by their age here. So we definitely do not satisfy element 2. Now the third one is about replication. And for this, we need to have multiple experimental units. And we definitely do. We have 25 experimental units in the first treatment and 25 experimental units in the second treatment. So definitely replication has been satisfied here. Now remember, the question is asking us for which of these is missing. The one that is missing is definitely not random. And the other treatment, for the other treatment, this is definitely not random assignment. They were assigned by their age here. So we definitely do not satisfy element 2. Now the third one is about replication. And for this, we need to have multiple experimental units. And we definitely do. We have 25 experimental.
Okay, we'll make a note here. I'll do this in like purple, a different color. Okay. I got a text. How the bonkers? Oh, I texted this guy. Okie dokie. So this is her. So notice the different color.
Experimental units in
So
the first treatment,
now we know
and
what
25 experimental
replication
units in the
is.
second treatment. So definitely replication has been satisfied here. Now remember, the question is asking us for which of these is missing. The one that is missing is element 2, and so answer choice B is the correct answer here. All right, here we go. Question 3. The probability that a particular electrical component operates successfully is 3/4. An electrical system consists of 3 such components that operate independently. The system will function successfully if at least one of the 3 components operates successfully. What's the probability that the system will function successfully?
At least one of the 3. Okay, let me redo this one real quick because so this time it's just going to be the probability that none of them succeed. So it's going to be the 1 minus and then the probability that they one. So the probability of at least one succeeding is going to be the probability of none of them succeeding. But there's another way to do it. So none of them succeeding is going to be 1/4 times 1/4 times 1/4. So it's going to be this equals 1 minus. And you can also do, so because it's going to be the probability where x equals 1, and then you have, so out of 3 trials you have 1 success. It's in here if you don't know what it's going to be. So it's the probability times the number of successes, the probability of success, and then 1 minus the probability of failure. So it's going to be and then that should yield the same answer. And to calculate this, you can just do NCR, and then you get. Let's try both ways, just to see if I'm speaking logically here. So the NCR equals 3. So then this is going to be 3 times 3/4 times 1/16. Then you'll notice this becomes 9/64. Okay.
Now here's our answer choices. A says 1/64, B is 27/64, C is 37/64, D is 3/4, and E is 63/64. Now I think a visual is going to help on this one here. So we've got this system here that has 3 components. So think about each one of these rectangles as being one of the components. And what we will define S as the component operating successfully, and we know from the problem that probability is 3/4. So I'm just going to label each one of the components here with the probability of success. Now overall, for the system to function, we need at least one of these components to be successful. Now when I say at least one of these components to be successful, that's challenging to calculate because it could be the first one that's successful, or the third one,
I just
or the first.
realized the phone call I got was from a number I knew. Or it wasn't. Okay. I'm a liar. Sorry, Brandon.
First one and the second one, or the first one and the third one. So we're going to use a little trick here by finding the probability of the complement and subtracting it from 1. Now the complement to at least 1 is none. So we're going to do 1 minus the probability that none of them are successfully working, that all 3 of the components have failed. So we need the first component to fail, and the second one to fail, and the third one to fail. Now we know the probability of them succeeding is 3/4. That means the probability of each component failing is 1/4. And because those are independent of each other, we can simply multiply those 1/4 to find the probability that all 3 of them fail. 1/4 times 1/4 times 1/4. And then we subtract that from 1 to get our final answer of 63/64. So the correct answer here is answer.
So yeah, after reevaluation, this is correct. Let's see. I'll write his example down, sure. Let's just say working component. Each get their own little box. And then so P of function equals P of there. And then also then P of at least 1s will equal 1 minus P 0s there. Those are, I think that's good enough.
Choice E. All right, question 4. The driving route between the student's home and the student's high school has 2 traffic lights. The distribution of total time spent driving has mean 5 minutes and standard deviation 1 minute. The distribution of time spent waiting at a light has a mean 0.75 minute and a standard deviation of 0.25 minutes. The total time spent driving and the time spent waiting at a light are independent. The total travel time from the student's home to the student's high school consists of the total time spent driving and the time spent waiting at 2 lights. What are the mean and standard deviation of the total travel time? So here's our answer choices. A says that the mean is 5.75 and the standard deviation is 1.03. B says the mean is 5.75 and the standard deviation is 1.06. C says the mean is 6.5 and the standard deviation is 1.06. D says the mean is 6.5 and the standard deviation is 1.12. And E says the mean is 6.5 and the standard deviation is 1.5. So let's see if we can get organized in the question here. I'm going to start with the driving time, which I'm going to define as random variable D. And we know the mean of that random variable is 5 and the standard deviation is 1. I'm just going to record this in the margin here. Now for the traffic lights, we're going to call that random variable L, which we know has a mean of 0.75 and a standard deviation of 0.25. So we'll just record that in the margin there. Now what we're looking for in this problem is the total travel time. And the total travel time can be found by taking the driving time plus 1 light plus a second light. That will give us the total driving time. So let's first think about calculating the mean of that total travel time. And just like you'd expect, you're just going to take the mean of D plus the mean of L plus the mean of L. We add those 3 up, and we find that the mean of the total travel time is 6.5 minutes. So right away, I can get rid of answer choice A and answer choice B because they have the incorrect mean. Now we need to move to standard deviation. So you might think that we can just find the standard deviation by adding the 3 standard deviations. But this is incorrect. Remember, one does not simply add standard deviations. This is incorrect. But what we can do is we can add
very serious. Hold on.
A, I can get rid of answer choice A and answer choice B because they have the incorrect mean. Now we need to move.
Okay, hold on. I'm going to send it to a friend.
Find that the mean of the total travel time is 6.5 minutes. So mean of L. We add those 3 up, and we find that the mean of the total travel time is 6.5 minutes. So right away, I can get rid of answer choice A and answer choice B because they have the incorrect mean. Now we need to move to standard deviation. So you might think that we can just find the standard deviation by adding the 3 standard deviations there. But this is incorrect. Remember, one does not simply add standard deviations. This is incorrect. But what we can do is we can add the variances. And this formula works because we know that those random variables are independent.
Okay, so hold on. So I already made a mistake.
Now to get the variance, and this one is the mean of. Now what we're looking for in this problem is the total travel time. And the total travel time can be found by taking the driving time plus 1 light plus a second light. That
You had 2 lights? Oh. Why are you... Okay. But here we're gonna do the new work in a different color. So it's going to be 5 plus 2, 0.75. So that equals 6.5. I'm already calling it. Let me draw that better, which equals 6.5. And so this is going to be 1 squared plus 0.25 squared plus 0.25 squared. And then so we know what it contributed. So I'm going to make an educated guess right now, and so it's going to be C. But I could be wrong.
will give us the total driving time. So let's first think about calculating the mean of that total travel time. And just like you'd expect, you're just going to take the mean of D plus the mean of L plus the mean of L. We add those 3 up, and we find that the mean of the total travel time is 6.5 minutes. So right away, I can get rid of answer choice A and answer choice B because they have the incorrect mean. Now we need to move to standard deviation. So you might think that we can just find the standard deviation by adding the 3 standard deviations there. But this is incorrect. Remember, one does not simply add standard deviations. This is incorrect. But what we can do is we can add the variances. And this formula works because we know that those random variables are independent. Now to get the variances, we're going to have to take our standard deviations and square them. And then we add that all up, and we get an answer of 1.125. And so you might think answer choice D is the correct answer here. But hold up. What we have calculated here is the variance. That 1.125, that is the variance of T. We need the standard deviation of T. So that answer choice D is incorrect. And in order to get our standard deviation, we're going to have to take the square root of the variance, which will give us a standard deviation of 1.6, leading us to the correct answer of answer choice C.
Okay, I'll write a note down here. In the red color this time, because these are my notes.
All All right, last question here. Number 5. A national newspaper reported that 40% of high school students engage in community service activities. The school administrator wondered whether the proportion of high school students at the administrator's school who engage in community service activities is less than 40%. The administrator selected a random sample of 100 students, and 36 responded that they do engage in community service activities. The conditions for inference were met, and an appropriate hypothesis test resulted in a p-value of 0.207. Which of the following is a correct interpretation of this p-value? So here's our answer choices. Answer choice A, the probability that a randomly selected student at this high school engages in community service activities is 0.207. B, the probability is 0.4 that less than 20.7% of students at this high school engage in community service activities. C, the probability is 0.207 that less than 40% of students at this high school engage in community service activities. D, if the proportion of all students at the school who engage in community service activities is 0.40, the probability of observing 36 or fewer in a random sample of 100 students who engage in community service activities is 0.207. And answer choice E, if the proportion of all students at the school who engage in community service activities is 0.36, the probability of obtaining 40 or fewer in a random sample of 100 who engage in community service activities is 0.207. In order to interpret the p-value here, I think it's important that we know what our hypotheses are. So looking back at the question, you see that the newspaper reported 40% as the value, but the administrator thought that it was less than 40%. So this gives us our null hypothesis of p equals 0.40, and our alternative hypothesis of p is less than 0.40. Now remember, when you're calculating a p-value and you're asked to interpret it, it is really a probability. And what it is the probability that we get the observed result, or more extreme, given that the null hypothesis is true. And that given part is the important part. This conditional.
Okay, here. P-value. So the probability of, just so I can write down everything, observed. Let's see if I can shrink that down in a smaller space. So it's the probability of observed slash more okay.
Probability says that we are assuming that the null hypothesis is true. So the interpretation must sound like a conditional probability, where we're saying that the null hypothesis is true, or if the null hypothesis is true. Now, when you look at our answer choices, A, B, and C, they have nothing that sounds like a condition in those. And so I'm going to get rid of those 3 answer choices. And if we look at D and E, the one that says we assume the null hypothesis is true is answer choice D, because it says if the proportion of all students at the school who engage in community service activities is 0.40, which is exactly what our null hypothesis is. So that's exactly the conditional probability we were looking for. So thank you so much for joining me for session 2. I certainly hope that you will join my colleague Darren Starnes in session 3, where he'll talk about free response for exploring data and collecting data.
Subscribe. Okay, now we have a reflection. So, 2 sentences. As seen by the problems I got wrong, or as I should say, as evident by the problems I got wrong. I don't think I have any. It doesn't look like I'm missing any important emails. So, as evident by the problems I got wrong, I've learned of 2 things I need to hone in on. Firstly, understanding the parts. Replicability, or is that the word? Yeah, replicate. Yeah, replicability. Understanding the different parts of an experiment, and reading the problem. I didn't see that there were 2 stoplights. I got a text message. You da early bird. You da real early bird. Hope you got many worms. Thank. Thumbs up. There we go. All right. Sorry, my friend's texting me. Oh, yeah. My back is freaking itchy right now, dude. Okay. Gonna give you turn to something exciting. Let's actually do. I have a favorite one for this one. It's the castle theme. Yeah, there. I think that's a good reflection. Okay. This looks sufficient, yeah. What is it? I will be right back. I'm a little hungry. Mom? Think of me fondly when you say goodbye. You like my singing? Alright. I got beef jerky. Look at this. Yummy. We're just testing, right? Now it deactivates. Okay. I don't mind the waiting. Okay. Review 3. I freaking knew it. You said it was free. You lied.
You look kinda sad. Give me just a moment and I'll make you glad. If you don't want any help, just say. You know I've got a PhD in brightening days.
I just want to take a look. See.
What I see in you.
Oh, just right away. Okay.
Let me tell you what I see is true. My eyesight's fine and I'm rather in my mind.
Ah, the expansion is free. Just notice this. It is on here. You put it on. What are you talking about? What are you talking about? What are you talking about? They even put saluting the fallen. If you don't know what that is, it's it was because Rick May died from during COVID, I think of COVID, and so he yeah, and so they honored him in tribute. It's very beautiful, actually. Best of Fortnite. What? What the freak? What are we doing? I want to buy a Minecraft Stadium. I love Minecraft. No! No! I don't really care. It's okay. An additional $200 of shipping. Take a look. 2. Oh, never mind. I guess not. Okay. We're getting distracted. FRQ. Sorry, you're a little squished there, buddy.
Hello, AP Stats.
Hello, how long is the video? Okay, they're all 13-ish minutes. Is it part of the study? Okay. Let's see here. Thought I was going crazy. Alright. As a part of the study on Alaskan streams, the researchers took water samples from many streams. Describe the distribution. Okay. So the distribution of dissolved oxygen in streams. My finger is oily. In streams warmer than 8 how do you write degrees 0176 8 degrees C is left skewed because okay, so if you don't know, if you want the tips, CSOX, that stands for context, spread, outliers, or I guess you could start with shape. What's what I'm doing? Shape, outliers, center and what's the other S? Hold on, I said shape and spread. So yeah, make sure you address all those. So is warmer than 8. The distribution is left skewed with a mean of, or do we use a median? I think we use a median with a median of 5.34 milligrams per liter. Liter? Yeah, I thought liter was L, but whatever. I'm gonna copy their units. There are let's calculate that real quick. I assume we have to. So let's see. So we're going to do 4.39 minus 1.5, and then the IQR is, let's see if we can do this in our head. Okay, 61, 73, 1.73, 1.73 equals here, 4.39 minus 1.5, 1.73, so that equals 1.795. Looks like a 4, 795, and then we have 6.12 plus 1.5, 1.73, which equals, let's see, 6.12 plus. There's a lot of outliers based on the IQR. 8.715. If I did this correctly, which I'm pretty sure I did. Get these Grammarly things out of my way. Okay, with a minimum of... Why is all the data above? Are we sure? Because now I'm doubting myself, but this is most definitely the right thing. Well, we'll see with a minimum of, okay, 46 plus 89. Using the IQR, there are many high outliers with a minimum of there's no freaking way 386. This doesn't feel right. I'm gonna let them explain that to me, but that's what I calculated based on the IQR. But then that's saying I'll write both just so I can, then we can identify once we get to the video. Alternatively, how There is no way. There's no way that this is the mean. How can the mean be 5? Oh, what? I'm not writing this part down. This whole question is freaking weird. Okay, the minimum. Okay, whatever. So we did outliers. Now we need to do spread. The IQR of the distribution is 1.73 is what 1.73. Okay. So we did shape, center, outliers, SOCS. Okay, and then so we just needed to do spread and the IQ. Alright, that should be, yeah. The researchers computed the summary statistics shown in the table for the dissolved oxygen concentration streams. Use the summary statistics to construct a box. So are you saying that this is not for this problem? This is for the other problem? Oh, gosh, freaking. Okay, well, we calculated the IQR for the other one. Okay, construct a box plot. So our minimum is 2.1, so it'll be... This is 0.5. It'll be about here. Our Q1 is around 4.4. Our median is 5.4. Our Q3 is 6.12. And then our max is 13.45. Okay, so this is for colder. Where the freak did I get warmer? Wait, no. Where the freak did I get warmer? Skewed. We can calculate it. Okay, so there are... Let's figure how many terms there are. 1 plus 1 plus 1 plus 13 plus 12 plus 15 plus 40 plus 94 plus 117 plus 89 plus 46. So there's 429 if we divide that by 2. So our 215th is our median. So we could also just go 215 the other way. This is 200. So this is most certainly less than 215, and this is most certainly greater than 215. Therefore, it must be contained here. Is the median between 11 and 12. Between 11 to 12. It's somewhere in here. Okay, so there are potential lower outliers. There are potential lower outliers at the 2 to 3, 4 to 6 ranges. We can calculate the IQR. So we're just going to divide. So 214 divided by 2. It'll be the 107th and 108th term. from the ends. So I can guarantee, okay, so this is about 45, so this will be about 95. So it's going to be in here. Okay, so it's going to be from 9 to 10 to, and then I'll rewrite this, I just need this to write it down for now, to 12 to 13. So it could either be the smallest or the greatest. So it could either be from, it'll be 2 to 4, from 2 to 4. So basically what I did there is I take these ends, and then so this makes the smallest possible, and then took the ends, which make the largest possible. So from 2 to 4. Okay. You just believe the streams. You give me no room to justify my answer. Let's see. Believe that with higher dissolved oxygen concentrations are generally healthy. Okay, so with higher oxygen, with higher concentrations. I'll just put this on a new page. Okay, so, or C. I did not remember it. Let's see. What the freak is that? Is that a gun? Okay. Is it greater than? Yeah. Sans Undertale! No! They killed Sans Undertale! No! This is so sad. Okay, we literally just listened to this. Oh, it's part 2. Okay, we did not just listen to that. I like this one. Alright. Streams are generally more healthier than warmer streams, as evidenced by the medians and IQRs of the distributions. The distribution for oxygen concentrations in colder weather has a median between, I think it was like, what, 10 and 11 or 11 and 12, between 11 and 12 with an IQR of 50% of the data could be between milligram per liter of the distribution of oxygen concentrations in, let's see, streams, warmer streams, distribution of oxygen concentrations in warmer streams. Four point 4.396112. My back is killing me. Let's see. Less healthy. Okay. Oh, so many errors. All right. Q2. I'm gonna write it here. This is so the experimental units. Who are they? Let's see. Homes that need driveways. I remember this problem. All right. Describe an appropriate method to randomly assign. Okay. This is what I'll do. We'll just put everything down here. 1 to 60. Generate generate this is hard to read. I'll just do the paper one. Write down on 60 pieces of identical paper, write down the unique numbers from 1 to 60. How? Did I just not put spaces between these? Because I most definitely did. Excuse me, for a total of stop. Okay, this is probably wrong. I'm probably remembering it incorrectly, but I don't care. Yeah, we can save a little bit of room by moving this back up here. Okay. Suppose the development price are statistically safe. What? I like this one too. Okay. In terms, what is the benefit of randomly aside from the drawer? You see the concrete that contains fibers or the concrete that does not contain fibers. Okay. The true that the difference in crack intensity is actually caused by the independent not some confounding variable. Thank you for example location. So that's usage. Okay. All right. That's the FRQs done. Let's take a look at that.
Students. I'm Darren Starnes, longtime AP Statistics teacher and exam reader from Hilton Head, South Carolina. In sessions 1 and 2, Mr. Wilcox focused on the multiple choice section of the AP Statistics exam. This session dives deeper into free response questions focused on exploring data and collecting data. Now be sure to download the questions and try all of them before you continue. If you haven't done so already, feel free to pause the video if you need to do that. You'll get a lot more out of the session if you've tried everything before I discuss it. Let's look at the first question. As part of a study on the chemistry of Alaskan streams, researchers took water samples from many streams with water temperatures colder than 8 degrees Celsius and from many streams with temperatures warmer than 8 degrees Celsius. For each sample, the researchers measured the dissolved oxygen concentration in milligrams per liter. Now, it might surprise you that in the question, the graph appears already even though it's not been mentioned. That's fairly common on the AP Statistics exam based on how the question needs to be formatted, but we notice so far on the vertical axis is frequency, on the horizontal axis is dissolved oxygen concentration. But fear not, the reference to the graph is coming up very shortly. So here's part A. The researchers constructed the histogram shown for the dissolved oxygen concentration in streams from the sample with water temperatures colder than 8 degrees Celsius, and we can see that reference on the horizontal axis. Based on the histogram, describe the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 degrees Celsius. So after I've read this part, I want you to notice a couple of key phrases. One is based on the histogram, and the other is describe the distribution. So we need to use the histogram that we see to describe the distribution. And that should prompt in your memory from your course several things that you should include in your description. Shape, any outliers or unusual features, center, variability, and context. Those 5 things should always be present in the description of a quantitative data distribution. So here's an example of how you might write out a solution in paragraph style. So it says the histogram of dissolved oxygen concentration in Alaskan streams with water temperatures colder than 8 degrees Celsius is unimodal and skewed left with a median between 11 and 12 milligrams per liter.
Put this here. I think I seem to always forget that. Unimodal.
Sure. Let's see what we've got in that first sentence in terms of characteristics. We have the context, that's the variable name in units. We can check that off. And then we also have the description of the shape, unimodal and skewed left, or single peaked and skewed left. We can check that off. And we also have a measure of center, the median, is between 11 and 12. We found that by counting over in the bars of the histogram until we found the midpoint of the data values. Now we still need 2 other characteristics, so let's keep reading. The first quartile is in the bend from 10 to 11 milligrams per liter. Again, we did that by finger counting across until we got to the 25 percentile mark. And the third quartile is in the bend from 12 to 13 milligrams per liter. We did that by counting from the right-hand side of the graph. So the interquartile range, or IQR, is approximately 2 milligrams per liter. There's another characteristic. We've got our measure of variability, the IQR. What's left? There do not appear to be any high outliers, but there are several potential low outliers in the distribution down here. Without testing and using the summary statistics, we won't be able to figure out exactly which are outliers. So we're just going to say there don't appear to be any high outliers, but there are several potential low outliers, since the values down there in the 2 to 3, 4 to 5, and 5 to 6.
Yeah. Potential low outliers at these ranges.
Bends are all certainly more than 1.5 IQRs below the first quartile, because 1.5 times the IQR would be 3, and the first quartile would be like 10 to 11. So if you'll notice, we've got all 5 characteristics discussed. I chose to do this one in paragraph style, but you could certainly use some kind of bulleted list structure if that's easier for you. Just be sure to include all those characteristics. All right, let's move on to part B. Once again, we see some visual displays. We have a table at the top, and we have a grid at the bottom for a graph. Part B says, the researchers computed the summary statistics shown in the table, that's at the top, for the dissolved oxygen concentration in streams from the sample with water temperatures warmer than 8 degrees Celsius. So we switched over to the warmer streams now. Use the summary statistics up in that table to construct a box plot for the dissolved oxygen concentration in streams with water temperatures warmer than 8 degrees Celsius. Do not indicate outliers. That was a bit surprising when we saw that on the exam, because usually students are asked to construct box plots with outliers, but it specifically says use the summary statistics to construct a box plot and do not worry about outliers. So that'll save us some time and energy. If you didn't notice that, there are 2 problems. One, it would take you a little while to check using the 1.5 IQR rule whether there are outliers on either end. And second, you would lose credit because it says don't indicate them. So let's focus on first the median, that's the sort of middle of the box, and we'll draw a line segment there around 5.43. And then next we'll go to first quartile, 4.39, draw a vertical segment around 4.39 on the horizontal axis. And finally, to finish the box, we'll draw a vertical segment at 6.12, roughly on the horizontal axis. And then we'll complete our box for the middle 50%. Then for the whiskers, for the left whisker, we'll go down to about 2.1 on the horizontal axis. And on the right whisker, because it says don't indicate outliers, we'll go all the way up to 13.45. Notice that there have to be outliers because the 1.5 of the box length would definitely not get you all the way to the maximum. You can sort of visualize it there. But that's it for part B. We've made the graph. Final part. C says, the researchers believe that streams with higher dissolved oxygen concentration are generally healthier for wildlife. Which streams are generally healthier for wildlife? Those with water temperature colder than 8 degrees Celsius, or those with water temperature warmer than 8 degrees Celsius. Use characteristics of the distribution of dissolved oxygen concentration for temperatures colder than 8 degrees Celsius, and characteristics of the distribution of dissolved oxygen concentration for temperatures warmer than 8 degrees Celsius. Justify your answer. So a couple of key phrases there. Which streams are generally healthier for wildlife? We need to answer that question, colder or warmer. Using characteristics of the distribution, you know what that means. And we have to include both distributions for the streams colder than 8 degrees Celsius and characteristics for the distribution of streams with the dissolved oxygen concentration for the streams are warmer than 8 degrees Celsius. To help you out, here are the graphs from part A from the colder streams and part B from the warmer streams. So what should we include in our answer? Well, you know those 5 characteristics. So let's look at a possible response. If the researcher's belief is correct, then streams with water temperature colder than 8 degrees Celsius are healthier for wildlife. So we've answered the question of which stream is healthier, which stream type. The shape of the distribution of dissolved oxygen concentration for colder streams is skewed to the left. The shape of the distribution of values for warmer streams is skewed to the right. So we've addressed context and we've addressed shape in that one sentence. You can see that you can combine several things into one sentence. The distribution of dissolved oxygen concentration for colder streams has a higher center since its median. Notice that we've given numbers between 11 and 12 milligrams per liter is larger than the median for warmer streams, and we've given a number there of 5.43 milligrams per liter from the table of summary statistics. So that takes care of center. The final sentence says both distributions have a similar spread because they both have similar IQR values, approximately 2 milligrams per liter, there's no numerical evidence, and 1.73 milligrams per liter, 2 for the colder streams and 1.73 for the warmer streams. So we've got our measure of variability. We don't discuss outliers in this case because we were told in part B not to include them. So that's one thing we don't have to do. So I think
Okay, let's see. So really, it's not as hard as you.
give you a sense for exploring data. Let's move on now to question 2, which is about collecting data. It says a developer wants to know whether adding fibers to concrete using paving driveways will reduce the severity of cracking, because any driveway with severe cracks will have to be repaired by the developer. The developer conducts a completely randomized experiment with 60 new homes that need driveways. So what do we got there? A completely randomized experiment. 30 of the driveways will be randomly assigned to receive concrete that contains fibers, and the other 30 driveways will receive concrete that does not contain fibers. After 1 year, the developer will record the severity of cracks in each driveway on a scale of 0 to 10, with 0 representing not cracked at all, and 10 representing severely cracked. So in that paragraph, we've got 30 driveways randomly assigned, and we've got concrete that contains fibers for those driveways. The other 30 driveways will get the concrete that does not contain fibers, and at the end, they'll measure severity of cracks. So part A says, based on the information provided about the developer's experiment, identify each of the following: experimental units, treatments, and response variable. It's really important that you know your vocabulary when it comes to data collection methods, whether it's sampling or experiments. So the experimental unit is the smallest piece of experimental material to which a treatment is applied. In this case, that would be the 60 driveways. Notice that the 60 houses would not be a correct answer. The treatment was imposed on the driveways. What are the treatments? Concrete with fibers and concrete without.
Hold on, let me make a note. Right. That's probably what got me. I was thinking about like what would get me.
Driveway. And that was the rating of the severity of the cracks after 1 year on a scale of 0 to 10. We want to give as much information as we can. Let's move on to part B. It says describe an appropriate method the developer could use to randomly assign concrete that contains fibers and concrete that does not contain fibers to the 60 driveways. So we're describing an appropriate method of random assignment. I'm sure you've practiced this in your class. First, we need to label or number the 60 driveways from 1 to 60. And then we have choices. We can use a random number generator to generate integers between 1 and 60 until we get 30 unique numbers obtained. Or we could write the numbers from 1 to 60 on identical slips of paper, put them in a big hat, mix them really well, and draw them out one at a time without replacement until we have 30 slips.
Okay, thank you for putting in both, because I would rather do random number generators, because I like those. RNG is what people... Yeah. Unique numbers, draw, mix evenly, draw a unique number without replacement, assign a treatment 1, rest a second.
Whichever way we do it, we want to assign the driveways with those 30 unique numbers to receive the concrete with fibers, and then the remaining 30 driveways would receive the concrete without fibers. There are other methods you could use, but these are 2 of the more common ones. And finally, as we move to the last part, suppose the developer finds that there is statistically significant reduction in the mean severity of cracks in driveways using the concrete that contains fibers compared to the driveways using concrete that does not contain fibers. So we have a statistically significant reduction. Part C asks, in terms of the developer's conclusion, what is the benefit of randomly assigning the driveways to either the concrete that contains fibers or the concrete that does not contain fibers? So we're being asked for the benefit of random assignment. Well, because the results were statistically significant, and because the driveways were randomly assigned, either concrete with fibers or concrete without fibers, there is convincing evidence that the treatment, type of concrete used, caused the response, which is the...
Caused by the independent variable, not some confounding variable. Difference in crack intensity. Okay.
Rating of severity of cracks. So when you use random assignment in an experiment, the purpose is so that you can establish cause and effect relationship if you have a statistically significant result. That's a really important concept in terms of what allows you to have that scope of inference. Well, we've looked at several important things about free response questions relating to first exploring data and then collecting data in this session. In session 4, Mr. Wilcox will be focusing on free response questions involving probability. And I want to thank you for spending time with me. I hope to see you in my next session.
Yeah, okay. Now it's time for our sentences. Always play it safe when describing distributions. In this case, not mentioning outliers. I was also reminded about how specific I should be of, what is it, characteristics of distributions, such as the how many and What exactly? Receiving the treatment. Oh, she's already grading my stuff. Ooh, each of them are 2 extra credit points, which means I have the potential to get. If I do all of them, I could get 16. What category are these in? Achoo! 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 Do you hear me sneezing? Okay, so these are these are, wow, they're going into the test category. Do you know how amazing that is? Okay, yeah, this is huge. Okay, so I've already gotten 4, so if I get 12 more, then that'll be 97.53 out of 300. That's really good for me. Okay. All right. Next FRQ. Yeah, see, graded. Let's see, did she write any specific notes? I'm not seeing any. All right. Oh, okay, so she did post something. Final written exam, common mistakes. Okay. Sweet. Thank you, Miss. Thank you, teacher. Hold on. Let me log in real quick. Freaking boy. Sorry. Oh, because that's not my password. Yeah. Hold on. A little bit of discrepancy. Sorry. Is it too late now to say sorry? Come the freak on, bro. Let's see, multiple choice, multiple choice. No! Give me the multiple choice! I also can't see. My guess is it'll open up later. See, I missed the effect size because I didn't know what it was. Even though we literally reviewed it like the day before, but that's okay. We did cook. We cooked with the EBQ. Look how much the total time I spent on the EBQ. You should. I need to email my teacher. I'm gonna ask her if I can open that up. Also, because I need to do a senior checkout list. So I need to return my books. So I will be back. Let me put something entertaining on. What the frick is this guy saying? I need to organize my video folder. No, do not put it in that one. Open a new VLC thing. Funnily enough, I actually look at this one was also recorded on a school day. Alright. Ready? Ooh, we can actually put all of these together and boom! Okay. Oops. I did the wrong one. Yeah. Well, center yourself. What? What are you doing? Center. Where are you going? Oh, 잠깐만! 하나만! Give me 1 second! No moment. 아이, 진짜, 잠깐만! There we go. Okay, we're back. That was 18-minute meal. That's not bad. Ugh, okie dokie. I was watching a video about Paganini. La Campanera. Yeah. Okay. So my phone is a liar, but alright. I'm getting exhausted, even though I've only done 3 stats things. So now we're gonna do number 4. I might take a break after we get halfway. Oh, this is not that long. Okay, but I do need a new page for this one. Also, I have some. Actually, what we're gonna do is we're gonna take part of a break now. I have ice cream, but it's not just any ice cream. It's Haagen-Dazs. I'm kidding. Haagen-Dazs. It's Haagen-Dazs. Okay, actually, let me show you my Haagen-Dazs. Look at this. Yummy. Oh, that was the. I thought this was making a really crunchy noise. It's really good. Turn on. Sorry. Turn the light back on. Okay. Usually the entertaining stuff I like to do when I'm what do you call it? Yeah, usually the entertaining stuff I like to do is watch TV. But I don't want to leech off of other people's content, so I'm gonna find a one-handed game, a game I can play with one hand. I have a friend who would love to see me play this one. Yeah. It's on mobile. For all your nubby needs. Alright. I have 3 stars, so I got Tony Jr. Go. I do not know the what do you call it? I do not know any of the combos. Also, I'll stop playing this as soon as I eat my ice cream because I want to get at least half. It's melting on my fingers. Let's see. Doubles 4 random pegs whose number is less than 32. This isn't meant to be helpful for long. Meat orb. Oh, this one. No, chocolate. chocolate is not to be wasted. Let's do. You have got to be kidding me. That was awful. Ah, so close. I think this will be good for early game. All right. Okay. We'll just finish this ice cream and keep moving. All right. Hold on. Funky parents. All right. Then I need to start unlocking more slots. I'm low-key not cooking right now. Almost skipped it. What am I doing? Yeah, no. What the freak just almost done with my eyes. Ah, sorry. Nice. So the most that make the less than 3 seconds. Not like that. Let's see. Marks a random bag. Oh, that's right, cannot be force trigger. You didn't even hit it? Are you freaking serious? Let's do force trigger that way. It's an investment. Nice. Look at that, times 7. We are cooking, ladies and gentlemen. We were cooking, ladies and gentlemen. We were cooking. Holy freak. Thank you. Let's see. Okay. I do like the sound of that. There we go. See, now we're making a return. So if you want to force That was weird. Okay, so I actually did finish a little bit ago. But we're gonna do this first. It's not worth 11 coins. Yummy. This is so sad. I am so sorry. Okay, now it's time to lock back in, unfortunately.
See what I see in you, but let me tell you what I see is true. My eyesight's fine and I'm rather in my mind. I've got you in my thoughts all the time. If I could take your hand and kiss you,
Just reading my stuff.
if I could
summer breeze or the winter frost.
Okie dokie.
Not a season's moment will be lost.
Approximately 3.5. Can you stop talking? Approximately 3.5% of all children. This is funky. Approximately 3.5% of all children born in a certain region are from multiple births, that is twins. Okay, one of children born in the region, 22% are left-handed. Okay, so this first one is... So the first one is, so the probability of probability of being left-handed given that they're in the region. I believe it's just 11% plus 22%. Because these are from multiple births, and then these are from single births, and they're independent from each other, and they're mutually exclusive. What is the probability that a randomly selected child born in the region is from a sample? Excuse me. Left-handed. Okay, so let's rewrite this one. So the probability that is multiple births given that they're left-handed. So that means the probability is this. So it's the probability of being middle and left-handed versus just the probability of being left-handed, which equals, so it's basically let's see. Yeah, it's the probability of 0.035, so multiple births and being left-handed, but then you subtract the amount that are both, which is 22, and then divide that by 0.33. If I'm wrong, that's what the video's for. Okay. Okay, we have one tiny issue. I got a negative number, so you could also draw it out as like a tree diagram. As in, so let's say hypothetically you have, like, let's say these are the probabilities of being single birth or not. So it's 0.5 and then 0.965, right? And then you have being left-handed. So, so actually I did this wrong. 11% left-handed. And then you have left-handed. So the actual numbers would be, where did I get 33? So this times 22 plus 0.965 times 0.11. Oh, I see. That's where I got it. Also, it doesn't just work like that. Let's figure out how to do that first part. So the probability this is the probability. Okay, so hold on. Okay, so this is the probability of being left-handed. So this is the probability of being left-handed, because then we take this into account, right? So that equals 0.1177. So then the probability of being multiple births, given that you're left-handed. So now we can say that the probability of being both is let's see, it's going to be 0.035 times 0.22 over the probability of just being left-handed, 0.1177. This should give us the right answer. Let's try. Because I got a really small number. 0.0. That's a 6. 0.0654. 5. A random sample of 20 children born in the region will be selected. What is the probability that the sample will have at least 3 children? Okay, how do we solve this? Let's look at our formula sheet. Okay. This is going to be binomial because we have a sample and we're looking for at least 3. So probability where x equals 3, which equals this, and the probability. Okay. So the probability of success, which is that they're left-handed, is this cubed. Because we are looking at this is the number of successes times 0.9823 to the 17th, because that's how many times we fail. So I'm pretty sure this is going to be a smallish number. But let's see. 23. There's 1,140 different ways that you can figure that out. It's like you could arrange the 3, and then we'll multiply by 0.1177 cubed times 0.9823 17th times answer. That's over 1. Oh, it's at least. Okay. So we actually need to do binomial CDF. And then so here. It's in your calculator. If you go to dist, you can go to the bottom, there's binomial CDF. And then so there's 20 trials. Our probability is 0.1177. Our X value is 3. But then what this calculates, if I remember correctly, it'll only do 3 or less. So what we can actually do is we can do binomial CDF 2, and then we'll do 1 minus our answer. So we'll do 1 minus binomial, and then we have 20, 0.1177, and 2. So this is our less than or equal to X. This is our probability, and then this is our N. And then so this equals 0.424. Okay, we will double check that with the video. Sorry, keeping it in perpetual limbo. The farm produces olive oil that is put into bottles. Let's see what the cork diameter of the bottles opening is this to provide. It should be from this to this. Okay, corks are purchased in bulk. Approximately normal. So let's note that. What is the probability the cork will be an acceptable fit? And so this is, let's see, this is going to be our low, upper, mean, and standard deviation. All right, and if we put that into our calculator, we get 30. That's not good. Wait, really? Only 30%? Well, I guess it is pretty far. Farm manager decides to purchase a corks from a new supplier. Good idea. 70% of corks have a diameter with the acceptable fit. At least 19. So again, what you can do, okay, we'll start it. Oops, because I need to write. Let's see here. So define the random variable of interest. The what? The variable of interest and state how the variable is distributed. It's distributed. I can't say normally. Because it's a new sub. All the information we have is that 70% are within. Oh, we can actually. I think we can do inventory for this one. Let's see. But you can only do that if you're assuming that it's in the. Yeah. Because we don't know the mean or the standard deviation. Supplier. Yeah, I don't know.
What y'all know about this?
So we're just not gonna answer that part because we'll learn. Just to be safe, just say distribute normally. What's the probability at least? So this is where we'll get writing. So here, we're gonna start drawing. So it's going to be the probability that x equals the probability that x. So this one is actually at least so that which equals 20 over 19. Probability of success is 0.7. We want that 19 times. Probability of failure is that, and then it's only going to happen once. And then so the way we'll do this, it's going to be 1 minus CDF, where total number is 20, probability is 0.7, and then it's going to be this is the minus of failures. So this is going to be n, this is going to be our probability, and this is going to be our x. And then this equals, let's see, I'm going to be doing this wrong, by the way. Don't take this like too seriously. But basically, it's a very small chance because it's going to be 7.98 e negative 4. It's very small. Alright. Let's see. Suppose corks are expected one at a time until an acceptable fit is found. What is the probability that W is less than or equal to 2? This one is another. Instead, this one is going to be a geometric. So it's where P is going to be less than or equal to 2. And then that equals. So if we double check our thing here. So the total amount of failure first. So it's going to be 0.3. Then we have success or failure. And then another way to think about this is you could just say, so what's the probability that it's found not that? So in 3 times. So it would just be probability where x equals 3, which in this would be 0.12 squared and then 0.7. So then those both should give the same thing. But if we do this way, then it's going to be geomet CDF. And then let's take a look. it's all the way at the bottom. I passed it. Of 0.7 and 2. Where this is the x, and then this is your p. And this equals 0.91. And you want to take a guess what this one equals? A number that's a lot smaller. Oh, 1 minus. Sorry. 1 minus that. Which equals 0.937. A little different. So, wait, hold on. Does it include or does it not include? Okay, well, whatever, it's that value, but let's take a look at the video now.
Hello AP Stats students, and welcome to AP Daily Practice Sessions, the absolute best way to prepare for the AP Statistics exam. My name is Luke Wilcox, and I'm an AP Stats teacher at East Kentwood High School, where I've taught AP Stats for almost 20 years. Now in this session, session 4, I'm going to take you through 2 free response questions related to my students' favorite topic, probability. Now I highly suggest that you download these questions and try them on paper first, and then come back to look at the video solutions. So let's jump right in. The first question says, approximately 3.5% of all children born in a certain region are from multiple births. That is, twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region who are from single births, 11% are left-handed. Part A says, what is the probability that a randomly selected child born in the region is left-handed? Now, this is a classic question where a tree diagram is going to be extremely helpful in solving the question. So let's set up the tree diagram here. We're going to start with all children in that region. And the first tree branch split is between multiple births and single births. And then for those that are multiple births, some of them are left-handed and some of them are right-handed. Now, same thing for those in single births. Some are left-handed and some are right-handed. Now, in this question, we're looking for the probability that they are left-handed. And there are 2 ways that this could happen. They could be multiple births and left-handed, or single births and left-handed. So we need to find both of those probabilities and then add those together in order to find the probability that they're left-handed. So let's start with multiple births and left-handed. So we see from the question that we know that 3.5% of children are born to multiple births. So I'm going to put that into the tree diagram as 0.035. Now, of those children born with multiple births, 22% are left-handed. So I'm going to put that in the tree diagram as 0.22. Now, to calculate the probability that they're multiple births and left-handed, we just simply multiply those 2 probabilities together. And that will tell us the probability that they're multiple and left.
Okay, we're learning.
Now let's consider the possibility of single birth and left-handed. And for this one, because we know that 3.5% are born multiple births, it is the complement of that, 0.965, that go to the single births. And then among the single births, we know 11% are left-handed. So we'll put that in as 0.11. So to calculate the probability of single birth and left-handed, we multiply those 2 probabilities together to get an answer of 0.10615. And now we add those 2 together to find the overall probability that they're left-handed.
That is almost not even close to
Now part B
what I
says,
got.
what is the probability that a randomly selected child, overall probability?
Okay, but I did the math the same, which means I'm going to conclude that you probably rounded. Hold on. Okay, no, I did some computational error.
That they're left-handed is 0.11385. Now part B says, what is the probability that a randomly selected child born in the region is a child from multiple birth, given that the child selected is left-handed? Now the important part of this question is that we are going to use some of the work that we've already done in the tree diagram. And in this question, we are given that the child selected is left-handed. That makes this a conditional probability. We are trying to find the probability of multiple birth, given that they are left-handed. Now on the formula sheet for the AP exam, there is a formula for a conditional probability. And the way I like to think about it is that it's the probability of both events divided by the probability of the given event. So in this scenario, where we're trying to find the probability of multiple births, given that they're left-handed, the top of the fraction has both multiple and left, and the bottom of the fraction has just the given condition, the probability of left. And actually, we've already done all of this work in the tree diagram. For the top of the fraction, the probability of multiple and left, that's the top of the tree diagram, 0.0077. And the bottom of the fraction is just our answer from part A, the probability of left. So overall, we end up with a conditional probability here of 0.0676. All right, part C says a random sample of 20 children born in the region will be selected. What's the probability?
Let me get the right answer from you. So this is, right process, wrong number from A. But it was really close.
0.0676. All right, part C says a random sample of 20 children born in the region will be selected. What's the probability that the sample will have at least 3 children who are left-handed? Now I'm going to take a specific approach to this problem here, a 3-step approach, which works very, very well for a lot of these probability questions. So first we need to identify the distribution. Well, I'm going to identify my random variable first, which is x, which stands for the number of children who are left-handed in a random sample of 20 children from the region. Now, from the question, we see that there are 20 children. This is a fixed number of trials, and we also know from part A, the probability of a success, if a success is left-handed, is 0.11385. So we have a fixed number of trials where the probability is the same for each one of those trials. Independent trials, this is going to be a binomial distribution, where the number of trials is 20, and the probability of success is 0.11385. Next, we're going to identify the correct event. Well, in the question here, it's asking for the probability of at least 3 that are left-handed. So what we're looking for is the probability that x is greater than or equal to 3. Well, now let's do the work and show the work to do our calculations. Now, the probability that x is greater than or equal to 3, we're going to use the complement rule here and find the probability that x is less than or equal to 2 and just subtract that from 1. Now that complement, the probability that x is less than or equal to 2, includes 3 possibilities. The probability that x is 0, or 1, or 2. So we're just going to find those probabilities and subtract them from 1. Now, in order to find those probabilities, we're going to use the binomial formula, which you can find on the formula sheet for the AP exam. So here's what the formulas look like with the numbers plugged in. And the final answer that we're going to arrive at here, after we subtract it from 1, is about 0.402.
Let me write that more legibly. 0.402. Okay.
Now, if you want to use your calculator instead of the binomial formula here, you can use binomial CDF. But very important, you need to make sure that you clearly label each one of the arguments for binomial CDF. So the 20 is identified as the number of trials, p the probability of success, and then you're telling it the upper bound of 2, and you're going to subtract that from 1, and of course you'll arrive at the same answer. All right, here's our next question. It says, a farm produces olive oil that is put into bottles that are sealed with a cork. The diameter of the bottle opening is 1.03 inches. To provide an acceptable fit, the cork diameter should be from 0.99 inch to 1.03 inches. The corks are purchased in bulk from a supplier, and the distribution of cork diameters is approximately normal, with mean 1 and a standard deviation of 0.05. Part A says, if one cork is selected at random, what's the probability that that cork selected will provide an acceptable fit for the bottle? Show your work. All right, here we go. Once again, I'm going to use this 3-step process to approach this probability question. And the first step is to identify the distribution. Well, right in the question, it says that it's approximately normal, with a mean of 1.00 and a standard deviation of 0.05. So I'm going to draw a picture to represent that normal distribution, and then clearly label it as having a mean of 1.00 and a standard deviation of 0.05. Next, we need to identify the correct event that we're trying to find the probability of. And here, we want the cork diameter to be between 0.99 inch and 1.03 inches. So in my picture here, I'm going to label those boundary values and then shade the region in between. And I'll define a random variable d as being the diameter of a randomly selected cork. And what we're looking for in this question is the probability that d is between 0.99 and 1.03. So now let's get to the work of calculating the probability. So the first thing that we'll do is we'll take those boundary values and we will convert those into z-scores using the z-score formula. And we get the z-score of negative 0.20 and 0.60.
Do you really
now,
have to do
we would go
that?
to table A now with those z-scores to find the area to the left of those values, which you see here. And we subtract those to find the area in between, which is going to give us our final answer of 0.305.
Don't have a
Now you can also do this with the
calculator,
calculator using normal CDF. Just make sure that you clearly label your arguments. Okay, the lower bound of 0.99, the upper bound of 1.03, the mean of 1.00, standard deviation of 0.05, and you'll arrive at the same answer of about 0.305. All right, next, the farm manager decides to purchase the corks from a new supplier. 70% of corks produced by the new supplier have a diameter with an acceptable fit. Part B, the farm manager is investigating how many corks in a box of 20 randomly selected corks will provide an acceptable fit. Consider the probability that at least 19 of the corks will provide an acceptable fit for the bottle. All right, I, define the random variable of interest and state how the random variable is distributed. And II, what is the probability that at least 19 of the corks will provide an acceptable fit for the bottle? Show your work. Once again, I'm going to use the same 3-step process to approach this problem. And first, we're going to identify the distribution, starting with defining the random variable. So here we're going to call x the number of corks in a box of 20 to provide an acceptable fit. Now in the question, we know that there is a fixed number of trials here, that's 20, and we know the probability of success for each one of those trials is 70% or 0.70. So once again, we have a binomial distribution here with an n value of 20 and a probability of success.
I get it. Okay. I literally even say what it is afterwards.
That's 0.70. Next, we'll identify the correct event, which is given to us right in the question here. We want to find probability of at least 19 successes here. That is, x is greater than or equal to 19. And now to actually find the probability. Well, if x is greater than or equal to 19, there's really only 2 possibilities here. Either x is 19 or x is 20. And because we know this is a binomial distribution, we can use the binomial formula, plugging in our values here, and getting a final answer of point.
So it would just be, it would be quicker to just do
0.00764. Now, if you want to use the calculator directly for this, you can use binomial CDF, just making sure that you clearly identify your arguments, n equals 20.
Okay, wait, but I did that. Then why didn't I get the same answer? This is literally what I put in. Well, this is the right answer.
Equals 0.7, and the upper bound is 18. Now notice here, with binomial CDF, I'm using the complement rule. I'm subtracting the probability that x is less than or equal to 18 from 1, and that will leave us with the probability that x is greater than or equal to 19. All right, part C. Suppose quarks are inspected one at a time until an acceptable fit is found. Let the random variable w represent the number of quarks inspected. What is the probability that w is less than or equal to 2? So we work. Okay, once again, we're using the same three-step process here. And the first thing is to identify the distribution. Now, they've already defined the random variable w to represent the number of quarks inspected. And you'll notice here that we're looking for quarks until an acceptable fit is found. This is not a fixed number of trials. In fact, we're looking for the number of trials until we get the first success. And we know the probability of success is 0.70. Now, this is not a binomial distribution because there's not a fixed number of trials. Instead, because we're looking for the number of trials until the first success, this is a geometric random variable with a probability of success of 0.70. Now, the event that we're looking for in this case is the probability that w is less than or equal to 2. And what possibilities does that include? Well, we could find the first success on the first trial or on the second trial. So that would be w equals 1 or w equals 2. Those are the only two possibilities. Now, for w to be equal to 1, that means we got a success on the first trial. And we know the probability of that is 0.7. So the probability that w is equal to 1 is just 0.7. Now, for w to be equal to 2, we would have to have one failure followed by one success. So that's going to be 0.3 times 0.7 in order to get the probability that w is equal to 2. We add those two together, and we get a final answer of 0.91. Now, once again, you can use a calculator function for this. It would be geometric CDF. Just make sure you identify your probability of success of 0.7 and the upper bound of 2, and you should arrive at the same answer. So thank you so much for joining.
Okay. We are finally good. Should I write? Because I need at least 2 sentences. It was good to see that calculators function your calculations. It was good to see that ouch. It was good to see that I need to use the calculator functions for these. Alright, sweet. Okie dokie. Well, I'll just make another note again. Alright. My current focus is not eating. It's AP stats. Okay, we're getting there. We are now halfway done. Okay, this one's only one. Because they're convinced, because this is an inference.
Joining me for session.
Hello, AP staff.
Hello. Alright. Let's take a look at this problem. Okay. Randomly assigned treatment. Excuse me. This is a matched pairs, so. What is the critical value here? We know it's mean, so it says a T. We know it's 2 sample, because there were 2 samples of people. Or was it 1 sample? No, but it has to be matched. Or did they already do that for us? T-test where mu of D is the true mean difference.
At students, free response, I mean, enter my solo. We've got or what's it possible? Took level of record score, which abo minus scores, omega statistical. Is there a significance test? We have a little bit of a puzzle here because we've been presented with extraneous information in both the table of summary statistics and the graphs. We have really 2 choices of inference method that might make sense. One is a 2-sample t-test for a difference in means, and the other is a paired t-test for a mean difference. Which is the right one? Well, a 2-sample t-test for a difference in means is appropriate if the data were collected by taking independent random samples from 2 populations and calculating the sample mean and sample standard deviation for each of those samples, or in a randomized experiment that's completely randomized with 2 treatment groups where there's a quantitative response variable, both determined the second, so sometimes called.
Yeah, okay. So we are right, but now we need to define the parameter. It's the true mean difference between and then so what we're saying our null hypothesis is that mu of D equals 0, so there is no difference. But the alternate hypothesis is that mu of D, since we're doing placebo minus omega 3, oh, I love this one too. Placebo minus 3. That we're going to say it's less than 0 because that means omega 3 had a greater effect. Because if it was positive, that means placebo is greater than omega 3, and then that means that let's see difference. Oh yeah, no, that would mean the placebo scores are higher. Actually, so we do want greater because that would mean the placebo scores are higher. So now we have to check. And so our conditions are, let's see, this was, ooh. Ramble, and then the second condition is the large counts. Oh no, it's that 19. Let's see, what are they? let's see, for mean. Let's see. I forget how to do that. We're going to review real quick. Or yeah, no, we're gonna review. Let's see. Oh, there's multiple ways to check the large counts. Okay. So that's right, because this one, it's either it says it's normal before. So it's either it says it's normal before it's n is greater than 30, or there. Alright, so now we can calculate, and then I'll give myself plenty of room for that. Oh my god, I hate it when you do that, because then you change the color of the font. Conclude. And then, so we need to calculate it first, obviously, so let's figure that out. Okie dokie. Alright, to conclude, so we're doing a t-test. So our test statistic equals, because it's matched pairs, it's going to be the value that was in here, so 1.789 minus 0, because that's our parameter, divided by this, so standard deviation over the square root of n. So the standard deviation was found to be 2.485 divided by the square root. There were 19, and then so this equals, let's see what we get. 1.789, 2.485. So we get a t value of, this feels a little high. I know how to do inferences, so
A matched pairs t-test for mean difference, or a one sample t-test for mean difference. Let's state hypotheses. The null hypothesis than 0. Difference is placebo minus omega-3 in irritability scores.
don't need to say that. Yeah.
All patients with this meta for mean difference. So we start with randomness in the data collection. In this case, the order of treatment for each patient, placebo followed.
We'll make some notes now.
By omega-3, and at random, we should not check the 10%.
There we go.
Condition here. Doing so when it's not appropriate will likely lose credit on an check, which is best what suggests that it's reasonable to believe that you can use our for the very at the bottom on here could use the table.
It is just a huge number, okay. Because then from here, what you can do is you can do T, C, D, F, where you have 3.138, which is our test statistic. And then you have the mean, which was 1.789, and then you have the SD 2.485. And then so from there, TCDF is right here. Or actually, that's not how it works. I was wondering why it felt weird. Okay, that's called hindsight bias, what I just did, by the way. So there's your test stat. Then actually you have, which is your low. And then you have infinity, which is your upper. Then you have your degrees of freedom. Since we had 19 patients, it's going to be 17. Or 18. You only do -2 if you have like 2 different variables.
That comes with the formula sheet on the exam, and use the t distribution table. Want to even consider using technology to get the t statistic, certainly to at least check the value of the t statistic we got there. So this is an example from the TI-8384, and we can see that the t-test gives t is 3.138, so that's what we got, and a p-value of 0.0028. The degrees of freedom is not shown there, but in a one sample t procedure, it's just the sample size -1.
I was right. Okay. So you could do TCDF. But then actually you because then you can get a p-value from this equation. So the p-value equals same thing here, 0.0028. And then so I do know how to conclude from here. So to conclude, since 0.0028 is less than, did it ask for, 0.05, we reject the H naught and have sufficient evidence that and then that should be good.
So the p-value is 0.0028, degrees of freedom is 18. As long as you have the correct t-statistic and the p-value with associated degrees of freedom written on your paper, that counts as what you need for the calculations. You do not have to show that. And in the interest of time and accuracy, some of you probably don't want to show that because you might make some kind of arithmetic error or monkey up the formula somehow with moving things around. So my recommendation is to consider using technology primarily to do this piece correctly. Final step, we need to make a conclusion in context. So again, recapping the hypotheses and our p-value that we just got, 0.0028, we would say, and I'm sure you've rehearsed this in your class, because the p-value of 0.0028 is less than alpha equals 0.05, which we were told in the question, we reject HO. Second sentence, the data provide convincing statistical evidence that the omega-3 supplement will decrease the mean irritability score of all patients with medical condition similar to the volunteers who participated in the study. Did I make up the wording in that second sentence? I did not. I borrowed all of it from the stem of the question as we've been going through it. That just helps ensure that I don't freelance and say something that isn't quite what I should be saying. So I'm recommending that you parrot the stem of the question in your answer, just so you don't accidentally change a word that would unfortunately make the meaning incorrect. Wow, we've done a full inference procedure in this case of significance test, and you've seen the
Okay, now we'll put my additional notes down here. To be honest, the hardest part about this inference question was just remembering The nice thing about these reviews is they're all for extra credit. I'm sharp, sorry, not a good result. Grammarly, if you're not gonna help it, stop showing up. Go away! Why are you opening it in here? You took forever to open. This is stupid. Okay. This one was easier. We've done a billion inferences. Also, inference was the last thing we did, so. All right, this is done. So there's just 6, 7, and 8.
Hello, AP Stat
Hello, Mr. Wilcox.
students, and welcome to AP Daily Practice Sessions, the absolute best way to prepare for the AP Statistics exam. My name is Luke Wilcox.
Told you. All right. Number 6. This is spaced out horribly, by the way. Okay, I'll answer them down here. So, Q1A, it says, describe the relationship. Okay, so when describing the relationship, it's CDOFs. So you have what is it called? The relationship between, okay, you know what, actually, we're gonna do this because it's all the way on the other side. It's easier on paper, right? But we're not on paper. What the freak did I just see? Oh, hold on. forgot to sign it. 'Cause I'm an idiot. Alright, anyways. The relationship between... And then we're just gonna... Oh, and I have to change the color of the font too. Between chest circumference. That's not how you spell circumference. Is that not circumference? Oh my god, stupid English. Circumference and you're just stupid. Is seed ops direction, outliers, form and strength is strong and to have any drastic outliers. I think that's it. Hold on, let me think. Okie dokie. Ra, 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 ra. Okay, sorry, I'm just reading a message from my teacher. Only uno month de escuela left. How do you make that noise? Sorry, I'm being distracted. I think we did it all because we have context, strength, oh, we have direction, strength, yeah, linear. Okay. equals 1 times 1. I'm not locked in right now. It might be time for a break. Y hat equals, let's see, so it's going to be negative 350.3 plus 3 point. Make sure you use the right variable. Yes. 116.17. Stretching. Okay, y hat equals this. Make sure you don't forget your units. Kilograms. Long freaking problem. Let's calculate the residual. Okay, so you take your value and you subtract it from the actual value. Or no. You take the observed and then you subtract it from what the expected is. So the song is Loki Buns. The song is not. 8.13. Do residuals have units? I don't remember. I'll put a unit. For every additional centimeter, the male tool elk to increase by 3.45 I wrote 7455 kilograms. Why is it minor? There. Okay. Now we're on D. sendbar. Okay, let's see. Determine the p-value. You don't have to set up, you just have to determine the p-value. As it says, assume all inference conditions were met. Because these are... Okay, so this is a linreg. Oh, we're given the test statistic. Okay. 3.4. The p-value is because linreg tests, if you didn't know. Let's see. Linreg. I'm thinking really, really hard right now. I'm pretty sure it's T, so when I put it in my calculator, so here we'll do TCDF, where we have a test statistic 3.408. Oh, my back. 3.408 infinity, the degrees of freedom. I think this is what they're testing. It's 28. Do you know why? I bet you don't. I bet you don't. I bet you have no idea why. What the freak is this song? That is nonsense. Okay, this is better. And then this equals... Oh yeah, it's because there's two variables. That's why. Let's see. Yeah, I just froze for no reason. Why aren't all these test statistics huge? There, okay. That's question one. Now Q2. I have a feeling there was supposed to be more to this because it says I, but there's nothing else. Right. Teaching. Okay. Teaching year is recorded as an integer. That's important to know. With the first year is recorded as 1, second year is recorded as 2, and so on. So let's have a mean teaching year of 8.2. When you say first year teachers, do you mean like first grade, or do you mean like this is their first year teaching? That's significant to know. Let's data have a mean teaching year of 8.2 with the data recorded from 200 teachers at high school A and 221. High school B on the histogram, each interval represents possible integer values. The median teaching year for one high school is 6 and the median teaching years for 7. Identify which school has each median. Okay. How do you justify? We can identify that the... Okay. we can identify that okay, so there's 200 teachers at the average of okay. Yeah, definitely. I hope that makes sense. Okay, so basically what this is saying, because the way histograms work, it's values from less, so greater than or equal to 1, but less than 4. It does not include 4. So just reiterating there. Okay, I know this is algebra, I just gotta figure it out. Okay, so let's figure this out. We'll do this slowly. Let's add a whole bunch of room just in case, but for now, what we're going to do, so we know that mean equals, it's the sum of your terms over n. And we know 2 of these. So we know the mean is 2.5. See, so this is actually very easy. The sum of their means is 2.5, which equals, so you don't actually, we can figure this out in a second, over, because this is 18 different teachers. So we can actually figure out the sum by doing this. So 2.5 times 18 equals, let's see, so it's going to be 5 times 9 is 45. So 45, which equals this, let's say for new. Because now, right, and now we have the mean for the old. Do we know the mean for the old? Oh, we do, yeah. Okay, so the mean for the old equals, it's the sum of the terms for old plus n for old. And we know this to be 8.2 equals sum of that over 200. Because this is for school A. Yeah, for 200. And then so therefore 8.2 times 200 equals, it's going to be, usually it'd be 16.4, but we multiply by 100, so 1640. That looks like a 9, 1640. So let me double check that. Yeah. And then this equals the summation of this. And now, so you don't actually need to know these values, because to find the mean of the total, you just do that, right? And then this will find the mean of it all. Oh, I didn't know you could do that. Oh, that's so cool. Okay. And then so we can then put in our values. So we have 45. And it also note, it makes sense that these are whole numbers, because as we said before, teaching years recorded as an integer. So if we added all them together, it should also make an integer. Plus 1640 over, then we have 200. Technically it would be 18 plus 200. And then what this equals, .73, and that is the average. That's the average teaching year. Standard deviation for the teaching year is that if one of the teachers, what is the probability that the teaching year for the selected teachers within one standard deviation of the mean? I don't know how to justify this, but I can tell you how to do this. So, to figure out the probability, you're going to do normal CD. We can assume normality because n equals 221, which is greater than 30. Here, normal CDF is going to be, let's see here. So we want one standard deviation with the mean. Okay, I'm thinking. Or actually, what we can do is we can first do this. -1 to 1, 0, 1. Right? And this equals, and then this will give us hold on. It can't be that easy. Okay. Standard deviation of teaching year of this many people is that, right? If one teacher I'm pretty sure it's just this, right? Well, I guess we'll see if I'm wrong. Approximately 0.8. Well, actually, because we know it's not. So we can actually figure out, so 1 SD to 15.4. There's probably a more elegant way to calculate this. Let's see here. Oh yeah, it says that right there. Okay, hold on. Stop! There we go. Standard deviation is this much. If one teacher is selected at random, what is the probability that the teacher... Because it literally includes everyone except these people. I was gonna say 68%, but it's not normal, so we can't say that. But what could it be then? Okay, I literally don't know. So we are going to watch the video and learn. It'll be marked wrong. Don't worry, I'm not going to give myself extra.
And I'm an AP Stats teacher at East Kentwood High School, where I've taught AP Stats for almost 20 years. Now, in this session, I'm going to take you through 2 free response questions, both of which are multi-focus, a question that you are guaranteed to see on the AP exam. Now, I highly suggest that you download these questions first and try them on paper, and then come watch the solutions here in the video. So let's jump right in. Here's the first question. It says, wildlife biologists are interested in the health of the tule elk, a species of deer found in California. An important measurement of tule elk health is their weight. The weight of a tule elk is difficult to measure in the wild. However, chest circumference, which is believed to be related to the weight of a tule elk, can easily be measured from a safe distance using a harmless laser. A study was done to investigate whether chest circumference in centimeters could be used to accurately estimate the weight in kilograms of male tule elk. For the study, wildlife biologists captured 30 male tule elk, measured their chest circumference and weight, and then released the elk. The data for the 30 male tule elk are shown in the scatter plot. So here we see a scatter plot with chest circumference on the x-axis and weight on the y-axis. And part A says, describe the relationship between chest circumference and weight of male tule elk in context. Okay, this is a very classic question of describing the relationship between 2 quantitative variables. And there are 5 things you need to make sure you include in your response. So you want to include the direction, any unusual features, the form, the strength, and then of course this all needs to be done in context. So we're going to try and take care of all 5 of those in our response here. So here's what we have. The scatter plot reveals a strong, positive, roughly linear association between the chest circumference and weight of tule elk. There are no points that seriously deviate from the straight line pattern of the points in the plot. Now let's make sure that we hit all 5 of the important ideas here. For the direction, we said positive. For unusual features, we said that there weren't any. There were no points that deviate from the straight line pattern. For form, we said linear. For strength, we said strong. And then for context, we said chest circumference and weight of tule elk. A complete response that will earn full credit. Now, next it says following is the equation of the least squares regression line relating chest circumference and weight for male tule elk. The predicted weight is given by negative 350.3 plus 3.7455 times the chest circumference. Part B says the weight of one male tule elk with a chest circumference of 145.9 centimeters is 204.3 kilograms. Part I, using the equation of the least squares regression line, calculate the predicted weight for this male tule elk. Show your work. In part II, calculate the residual for this male tule elk. Show your work. Okay, starting with part I, we're looking for the predicted weight here. And it just so happens that we have this nice equation which will allow us to calculate the predicted weight. But what we need to know in order to use that equation is the chest circumference, which is given to us in the problem. So we just take that 145.9 and we plug it into the equation for the least squares regression line, and that's going to give us a predicted weight of 196.2 kilograms. Now part II, we're looking for the residual. And residual is defined as the actual value minus the predicted value. So here, the actual weight minus the predicted weight. Well, the actual weight of this tule elk is given as 204.3. The predicted weight we just figured out in part I. So we plug in those 2 numbers and we get a residual value that is a positive 8.1 kilograms. Next, we are asked to interpret the slope of the least squares regression line in context. So we're going to have to remember a few things from algebra class. Okay, first, you have to remember that the slope is the rise over the run, or the change in y over the change in x. In this case, the change in the predicted weight divided by the change in the chest circumference. Now, looking at our equation, we can identify the slope as being 3.7455. But I want you to think of that slope as being a fraction with 3.7455 divided by 1. And in this case, the 3.7455 represents the change in the predicted weight, and the 1 represents the change in chest circumference. And this is going to lead us to our interpretation of the slope, which says the predicted weight of a male tule elk increases by 3.7455 kilograms for each additional centimeter of chest circumference. Now, all of the words that you see in this interpretation are important. I want to highlight a few of them. The first one that is commonly missed is the word predicted or the word estimated, right? The equation of the least squares regression line is giving us the predicted weight, not the actual weight. Next, we're using the word increases here, and that of course is because the slope is a positive value. If the slope is negative, then we would say decreases. Next, we have the correct value identified for the slope. Next, we have correct units for both the y variable as well as the x variable. And finally, we have this word additional to represent the additional 1 centimeter, the additional change in x of 1. So that gives us a complete response that would earn full credit. All right, part D says the sandbar, another species of deer, is similar in size to the tule elk. The slope of the population regression line relating chest circumference and weight for all male sandbars is 4.5 kilograms per centimeter. A wildlife biologist wants to determine whether the slope of the population regression line for male tule elk is different than that for male sandbars. Let beta represent the slope of the population regression line for male tule elk. The wildlife biologist conducted a test of the following hypotheses using the sample of 30 tule elk. So here the null hypothesis says that the slope beta is 4.5, and the alternative says that the slope beta does not equal 4.5. The test statistic was calculated to be 3.408. Assume all conditions for inference were met. Part I, determine the p-value of the test. Okay, we have our hypotheses, and we actually already have our test statistic, which we know here is a t-test statistic because this is inference for slope. So we have a t-test statistic of 3.408. So let's take that to the t-distribution here. And if it's a t-distribution, we need to know our degrees of freedom. And in the context of inference for slopes, the degrees of freedom is given by n minus 2, the sample size minus 2, which is 28 here. Now, our test statistic t equals 3.408 is there, and we want the shaded area to the right of that. But also remember, this is a two-sided test. So I also need to the left of t equals negative 3.408.
It's two-sided. How did I just draw like a really good alpha, just like now?
So that's going to give us our p-value. Now, in order to get that, we're going to go to table B. And remember, our degrees of freedom is 28. So we go to the row where the degrees of freedom is 28. And now we're looking for our test statistic, or to see where it would land. And it actually is one of the values in table B, 3.408. So if we go to the top of table B, you can see that that is for a tail probability of 0.001. So that means that the area in the right tail of this distribution is 0.001. But remember, it's a two-sided test. So we need to double that value in order to get our p-value of 0.002. Now, you can also do this on your calculator using the TCDF function. And once again, make sure you double it because it's two-sided, and you have to make sure that you label your arguments for the TCDF function with the lower value, the upper value, and the degrees of freedom, and you'll arrive at the same p-value. All right, here's question number 2. The following histograms summarize the teaching year for the teachers at 2 high schools, A and B. So here we have 2 histograms, one for high school A showing the teaching year on the x-axis and the frequency on the y-axis, and then another histogram for high school B showing the teaching year on the x-axis and frequency on the y-axis. It says teaching year is recorded as an integer, with first-year teachers recorded as 1, second-year teachers recorded as 2, and so on. Both sets of data have a mean teaching year of 8.2, with data recorded from 200 teachers from high school A and 221 teachers from high school B. On the histograms, each interval represents possible integer values from the left endpoint up to but not including the right endpoint. So in those histograms, that first interval that you see from 1 to 4 represents teaching years of 1, 2, and 3, but not 4. 4 would show up in the next interval of 4 to 7. So here's part A. The median teaching year for one high school is 6, and the median teaching year for the other high school is 7. Identify which high school has each median and justify your answer. So once again, I presented the histograms here for high school A and high school B. And we know that the median is the middle value if you write out all the values in an ordered list. So let's start with high school A, which we know has 200 teachers. And if we were to write out the values for all 200 teachers, we know that the median would be between the 100th and the 101st value. So we're trying to figure out what would be the values at the 100th position and the 101st position. So let's just start counting them up. In that first interval from 1 to 4, we have 46 teachers. 4 to 7, we have 48, giving us now a total of 94. Not quite there yet. But when I get to that third interval is definitely going to contain the 100th value and the 101st value, which means that the median definitely has to be in the interval from 7 to 10, or 7, 8, or 9. And because we know one of the schools has a median of 6 and one has a median of 7, this one has to be the one with the median of 7. Now for high school B, we have 221 teachers. So for high school B, the median will actually be one of the values. It will be the 111th value in the ordered list. So let's see if we can figure out where that is. Well, the first interval has 79 teachers. And we add the number of teachers from the second interval, 34, and that brings us to 113 teachers, which means the 111th value had to be in that interval from 4 to 7. And so remember, that includes 4, 5, or 6, but not 7. So this is definitely the one that has the median of 6. Part B says an additional 18 teachers were not included with the data recorded from the 200 teachers at high school A. The mean teaching year of the 18 teachers is 2.5. What is the mean teaching year for all 218 teachers at high school A? Okay, so what do we know so far? We know that those first 200 teachers had a mean of 8.2, but then we're going to add 18 more teachers who have a mean of 2.5. And what we want to calculate now is the new mean of all of these teachers. Well, let's start by calculating the total number of years for the 200 teachers that we started with. Well, that's just 200 times 8.2. And then we're going to add the number of years for these 18 teachers that we've added by multiplying by 2.5. So that's what you see in the numerator. That's going to give us the total number of years for all of the teachers. And then we're going to divide by the total number of teachers here, which is going to be 218. And so this is going to give us a new mean of 7.73 years. All right, part C. The standard deviation of the teaching year for the 221 teachers at high school B is 7.2. If one teacher selected at random from high school B, what's the probability that the teaching year for the selected teachers will be within one standard deviation of the mean, 8.2? Justify your answer. Okay, here's the histogram again for high school B with the 221 teachers. And what we're looking for are values that are within one standard deviation of the mean. So let's figure out what those values are. Well, the mean we can see is 8.2 and the standard deviation is 7.2. So if we plug that in here and we add and subtract the standard deviation, we find that we're looking at the interval from 1.0 to 15.4 years. Now remember, these years have to be integer values. So 1 is okay, and 2 and 3, all the way up to 15, but definitely not 16. So we want all of the teachers between 1 year and 15 years. So let's see if we can find them in the histogram. So we're just going to start adding all these teachers up until we get to 15 years, which is in the interval from 13 to 16. Okay, remember, 16 goes into the next interval. And so here are all of the teachers with number of years of experience between 1 and 15. So we add all of those up.
This is me expressing my frustration.
To get 189. But remember, the question is asking for the probability. So we need to take that total 189 divided by the total number of teachers 221 to arrive at our final answer of 0.8552. So thank you so much for...
Okay, so I was on the right track. I just assumed you couldn't count it precisely enough, but you can. What? That's freaking crazy. Oh my god, I just got classic move. It's like my teacher's thing to take like 0.5 off. Let me see if the assignment's actually in here. This is fine. I don't need to do that because I already took it. I don't like that my internet's slowing. Lock in, bro. There we go. This is fine. Yeah, I'll just do it in person. Why is it collapsed by default? Here we go. All right. Yeah, no feedback. Just, yeah, you get 0.5 off. Thanks. This la-di-da is not helping. I'm gonna help with this, just so it's easier to read. Why are you not full? You know, when I draw a shape, I expect it to be full. Okay, there. All right, that should be good. We just have 2 more. All right, 7, but not yet. I think I have room, but let's see. Okay, I guarantee without just reading the bottom part. And then this equals, told you, something crazy like that. 2, 96, 304, 305. And then so this equals 0.576. Here. There. Alright. Jewelry company wants to make sure the machine is working properly. Cleo, the bathroom's free. Oh no, the condensation. Emma. Oh no, Cleo. Ribbit. Okay, I have 2 days to do that for him. I should do that for him soon. All right. See. So it's probably going to be a t-test, so we can tell. It's probably going to. So. Cleo takes. Okay. The probability that a gold applied. Would you believe me if I actually didn't know how to do this? I'm gonna move on because I actually don't know how to do that. Or is this the investigative
Hello,
task?
AP Stat students. I'm Darren Starnes, longtime AP Statistics teacher and exam leader from Hilton Head, South Carolina. In the previous session, Mr. Wilcox focused on...
This is the investigative task. Okay. The probability. Because it's 2. How do you do it with 2 though? I'm pretty sure. Would it be TCEF? No. Okay, I would like
the
to...
multi-focus pre-response question on our exam. In this session, I'm going to do a preliminary look at the investigative task, which is question 6. As always, be sure to download the question and try it completely before continuing. This question is long. You'll get the most out of this if you've attempted all the parts. So pause if you need to do that. Here we go. A jewelry company uses a machine to apply a coating of gold on a certain style of necklace. The amount of gold applied to a necklace is approximately normally distributed. When the machine is working properly, the amount of gold applied to a necklace has a mean of 300 milligrams and a standard deviation of 5 milligrams. Part A. A necklace is randomly selected from the necklaces produced by the machine, assuming that the machine is working properly. Calculate the probability that the amount of gold applied to the necklace is between 296 milligrams and 304 milligrams. I hope you heard. Calculate the probability. If you tuned in to session 4, Mr. Wilcox gave this 3-step method for approaching probability calculations involving random variables, like a normal random variable. We start by identifying the distribution. On the stem, it says that the population distribution of the amount of gold is approximately normally distributed, mean of 300, standard deviation of 5 milligrams. We can draw a picture, which we recommend to help you orient, and we can also label that in 300,5. Next up, we need to identify the correct event. Let's discuss in part A. We want to see the probability of getting between 296 and 304 milligrams. So here's our picture, and we'll label them. We also could write it in random variable notation. We let G be the amount of gold applied in milligrams. We can write the probability that way. Finding the correct probability, we have options. We can standardize, so find the z-score. We standardize the 296 boundary and standardize the 304 boundary by subtracting the mean and dividing all that by the standard deviation. We get negative 0.8 to 0.8. And again, you have choices here. You can use the formula sheet tables that give you the area under the normal curve, or you can use technology to find that probability. Here's the table values, 781 minus 2119 or 0.5762. Alternatively, you can just use your calculator technology from the get-go. If you're going to use this as your totality of your work, then you need to label the inputs of the command as I've done here. And you can see we get a more precise answer without rounding in the technology approach of 0.5763. Very similar though. That part should be familiar from things you've done. Let's move on.
Oh, shoot.
That part should be familiar from things you've done.
Yeah, that is the same answer I got.
Let's move on. This is a lot to digest, so if you need to pause the video to read carefully, I'm just going to hit the highlights. Clio's going to take a random sample of the necklaces produced that day and melt it down and see how much gold there is. Because they're going to destroy necklaces, Clio's only going to use 2 necklaces to do this. We're going to start by considering the mean amount of gold being applied to the necklaces. So Clio's going to calculate the sample mean after these 2 necklaces are melted down. Part B says, suppose the machine is working properly with a population mean amount of gold being applied of 300 milligrams and a population standard deviation of 5 milligrams. So part 1, calculate the probability that the sample mean amount of gold applied to a random sample of n equals 2 necklaces will be greater than 303 milligrams. You know the strategy now. Let's identify the distribution. So we know the population distribution from before, approximately normal with a mean of 300 and a standard deviation of 5, but that's not the distribution we're calculating the probability on this time. We're focused on the distribution of the sample mean for sample of size n equals 2. So for that distribution, the random variable is x bar, the sample mean, for the amount of gold applied for 2 necklaces. The shape of the sampling distribution will be approximately normal because the population distribution is approximately normal, even though the sample size is small, like 2. The mean of the sampling distribution of x bar will be the same as the population mean, 300 grams.
Okay, so we'll see if I can get going from here. So it's going to be x bar because this is a sample. It'll equal the same, so it'll be 300. But the standard deviation is going to equal 5 over root 2.
That formula is given on the formula sheet. Also, the standard deviation formula is given on the formula sheet. Standard deviation of x bar is sigma over root n, 5 over root 2, which is 3.536. We can draw a picture to identify the distribution, and we can label it with the n notation as such.
We don't have to take it twice, because now we can just do normal CDF. I'll write this out. Then we're just gonna do, it's gonna be the same. So it's gonna be, well, actually 303 to infinity with this, and then that is correct. And that equals, let's see. We get 0.198. I said 8. And then I guess if we have to label our function again, I'm just going to copy this.
Next, we identify the correct event. Greater than 303 milligrams for the sample mean. We're focused on x bar. So we can write it in notation, probability x bar greater than 303, or we can illustrate it on the diagram as shown. It gives you an idea of how big or small that area would be. And then we find that correct probability. Same approach as in part A. We can standardize, find the z-score using 303 minus 300 over 3.536. That's 0.848 for the standardized score. And using the table, we get 0.1977. Using technology, we can go straight to the calculation. Again, if you're going to use this as your work, be sure to label the inputs or you won't get full credit for work. We get 0.1981, which is a more precise answer that doesn't require any rounding.
All right, let's try to do the rest of this on our own. So now I know how to approach this problem. Let's see. Suppose Clear took a natural random sample of n equals 2 necklaces that resulted in the same mean amount of gold applied to the 303. Would this... Okay, let's see if we can answer this on our own. I'm going to say... some extreme values would, that's, no, because there is There is still a chance, albeit a lower one. That's some extreme values. That's very prone to skew. Okay. Let's keep going. Leo would consider the variation in amount of gold. Because of the small sample, Clio will use the sample range of the data for the two randomly selected necklaces rather than use the sample. Okay, so Clio will use the sample range of the data for the two randomly selected rather than the sample standard deviation. Okay.
What y'all know about?
She will simulate the sampling distribution as a random samples. Interesting. Yeah, I'm not looking at that. Okay. I think I understand what's going on. Describe the sampling distributions. What? Describe the sampling distribution of the sample range for random samples of size n equals 2 from a normal distribution. Okay, I can try that. It's actually right skewed. So we got, let's see, we got shape. Let's see, socks with no apparent. Lower or higher outliers. Let's see, we'll look for median. So I'd say this is 11, 22, 33, 43. Let's say this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or yeah, ranges from 10. So 1, 2, 3, 4, 5. So between 0.4 and 0.5. And right side. Let's see. freaking hell? Let's see. Actually, one. Let's say 23. I love this song. So goofy. Check how the sampling distribution of the sampling changes as the value of the... you're gonna make me... Okay. I'm just copying and pasting these. According to that, or compared with. Did I just forget spread? I did. No, I did right. I did spread. The range increases. Center inspiration. This pool song is not it, by the way. Okay, suppose that 1 month later is checking. I'm going to say here. Just calculating. Maybe 2 observations in each sample. That's about 0.4, 0.7 to 0.9. Eleven, 15. Is it sample size? Yeah, sample ranges. I'm making this stuff up as I go, by the way. It's an investigative task, is what you're supposed to do. I don't even freaking know. Use the sample range of the data. I'm making this stuff up. This is fewer values of the original distribution will be contained in this new calculated distribution. Okay, I made that all up. Let's see.
Like we did in the calculation here. But both are close, and either one gets full credit. For B2, suppose we have took a random sample of n equals 2 necklaces that resulted in a sample mean amount of gold applied of 303 milligrams. Would that result indicate that the population mean amount of gold being applied by the machine is different from 300 milligrams? Justify your answer without performing an inference procedure. Be sure you see that. So the highlights, still doing the sample mean, and we're interested in 303 as the boundary value. But the question is, would it indicate that the population mean is different from 300? That's different either way. Could be bigger, could be smaller. So remember, don't do an inference procedure. We just use what we already calculated. We saw that the probability here is 0.1977. So what's the probability of getting a result at least surprising in either direction? It's twice that. So I've written that the population mean amount of gold applied by the machine is 300 milligrams. Probability of observing a sample mean that differs from 300 milligrams by 3 milligrams or more in either direction is about 2 times what we got in the previous calculation, which is 0.3954. That's pretty large, like almost a 40% chance.
Let's see.
So obtaining a sample mean amount of gold applied 303 milligrams does not indicate that the machine is not working properly in terms of the population mean amount of gold applied being different from 300. So if you follow that logic, the next few parts are going to make a little bit more sense. It starts to get investigated now, and things get kind of wordy. So Cleo's going to consider the variation in the amount of gold now that the machine applies to the necklaces. Because the small sample size, n equals 2, Cleo's going to use the sample range for the two randomly selected necklaces rather than the sample standard deviation. So we're considering variation, and Cleo's going to investigate the behavior of the range for samples of size 2. She's going to simulate the sampling distribution of the range of the amount of gold applied to two randomly sampled necklaces. She generates 100,000 random samples of size 2, independent values from normal distribution with mean 300 and standard deviation 5, which is what we started with, as remember correctly. The range is calculated from two observations of each sample, simulated sampling distribution of the range is shown in graph 1. So we're going to have to take a look here. We get to graph 1, this is the sampling distribution of the range when the population standard deviation is 5, i.e. the machine is working correctly. That whole process is repeated again for two cases when the machine is not working properly and the variability is too high. Sigma equals 8 in graph 2 to produce this sampling distribution of the sample range, and even higher variability sigma equals 12 to produce this graph 3 in the sampling distribution of the sample range. Questions coming up in part C relate to those graphs. So it says use the information in the graphs to complete the following. First, describe the sampling distribution of the sample range for random samples of size 2 from the normal distribution with standard deviation 5, as shown in graph 1. Those are our keywords and numbers. We'll focus on graph 1 up there. Shape, well, right skew. Center. Well, that's kind of eyeball where the 50% mark would be about 6. If you count over on the relative frequencies, you get about 50% starting soon. And variability is like from about 0 to about 24 or 25. And say the value of the sample range vary from about, say, 0 to 25 milligrams. That's C1. C2. Describe how the sampling distribution of the sample range vary from about, say, 0 to 25 milligrams. That's C1. C2. Describe how the sampling distribution of the sample range for samples of size n equals 2 changes as the value of the population standard deviation increases. So as we go down the graph,
freaking
how does the sampling
UC25
distribution change the population standard deviation? And increasing as it increases. So first thing that does not change is the shape. They're all skewed to the right. That's not a change. For the center, we can see that the centers of the distributions, the midpoint is getting further to the right. As the value of the population standard deviation increases, the center, median or mean, of the distribution of sample range length increases. How about variability? Well, the variability also increases as the population standard deviation increases. You can see it as you look down the graph. This is doable, even though it's part of the kind of investigative aspect of the question. You can do this based on what you already know. Final piece gets set up here. So remember, Cleo's going to consider both the mean and the variability of the amount of gold applied to the necklaces. Later on, a month later, Cleo checks the machine to make sure it's working properly, takes a random sample of 2 necklaces, and calculates the sample mean as 303, that number should be familiar, and the sample range is 10. That should be familiar also. Recall the machine's working properly if the amount of gold applied to the necklaces has a mean of 300 milligrams and a standard deviation of 5 milligrams. So that's the stem of part D. D1, consider Cleo's range of 10 milligrams for the sample of size n equals 2. If the machine is working properly, for the standard deviation of 5, that's the top graph, is a sample range of 10 milligrams unusual. Justify your answer. And we'll focus up there. There's 10. We're going to focus on 10 or greater as being unusual. Well, if we sort of eyeball count the heights of the graphs, I think I get about maybe 20%. So I would say from graph 1, it appears that a sample range of 10 milligrams or more would occur in about 20% of random samples of size 2 when the machine is working properly with sigma equals 5 milligrams. 20% is not that unusual. So a sample range of 10 milligrams is not unusual when the machine is working properly.
Why? It appears as something should be clear by 20% not unusual.
Final part. Nucleus 60% is not that unusual. Would occur in about 20% of random samples of size 2 when the machine is working properly with sigma equals 5 milligrams. 20% is not that unusual. So a sample range of 10 milligrams is not unusual when the machine is working properly. Final part. Nucleus sample mean of 303 milligrams and range of 10 milligrams indicate the machine's not working properly. Explain your answer. So we've got to focus on both of the things we talked about in this question to discuss whether the machine's working properly. You remember we looked at the sample mean and found out that that would not be very usual to get 303 or more if the machine is working
Okay.
properly. So as noted in part B2, the probability of the sample mean would differ from 300 milligrams by 3 milligrams or more in either direction. When the machine is working properly is about 0.3954, so having a sample mean of 303 milligrams is not unusual. Then we looked at the variability. In particular, we looked at the distribution of sample range. As indicated in part B1, probability of getting a sample range of 10 milligrams or greater when the machine is working properly is about 0.2, so having a sample range of 10 milligrams is also not unusual. So overall, no. Leo's mean of 303 milligrams from the sample and range of 10 milligrams do not indicate that the machine is not working properly. This is like a consolidation of everything that we've done in the question. In the next session, we'll take a deeper dive into the investigative task and try to unpack some of the key things you need to know. Really appreciate you tuning in and hope to see you for that session.
There's always something you can learn. There's not. Why? Okay. I got 1 hour to fulfill my deal. I think I can finish the last one in an hour. Yeah. Okie dokie. We are. Right. Uno more. The last one. Oh, sweet extra credit and good practice. This is another investigative task. But it is shorter, so that's nice.
Go beyond. Go beyond. Go beyond. Go beyond.
The announcer would be beyond. I'm kidding, but I'm not. Alright. The instructor of a train.
Go beyond.
Alright.
Go beyond.
So the instructor of a certain coding language hopes that as student scores on a pretest will predict the student's scores on the certification final taken at the end of the course. So the final this is
Hello, AP Stats students. I'm Darren Starnes, longtime AP Statistics teacher and exam reader, coming to you from Hilton Head, South Carolina. Welcome to the finale of AP Daily Practice Sessions. In this final session, I'll be diving deep into the investigative task, final question number 6 on our free response section. As always, be sure to download the question and try it before continuing with the video. It's important that you attempt each of the parts before you hear me go over them to get the most out of the experience. So if you need to pause and do that now, please go ahead. Here's the question. The instructor of a training course for a certain coding language hopes that a student's score on a pretest will predict the student's score on the certification final taken at the end of the course. The final scores indicate proficiency with the coding language. A random sample of students who completed the pretest and the training course was selected, and the final scores of the students were recorded. The following tables show summary statistics and computer output for a regression analysis of the sample. So a quick recap, they're hoping to use a student's pretest score about the coding language to predict their certification final score. They took a random sample of students who did the course and the pretest and the final. And here come the summary statistics that were referred to. We have the pretest and the final, the mean and the standard deviation. And then here are the computer output details for the regression analysis that were referred to for predicting the certification final score from the pretest score. So we have the column predictor, constant pretest, we have the coefficient column with some numbers, and then we have other values that we may or may not need during the question. We'll keep those handy, and let's take a look at part A. Identify the equation of the least squares regression line for predicting final score from pretest score. So that's what we're going to be doing. Identify the variables that appear in the equation in context. So I've highlighted the key things there. Let's make sure we do all of that. First and foremost, to find the equation of the least squares regression line for predicting final score from pretest score, you notice down here that the explanatory variable of pretest score is listed here. The coefficient of that explanatory variable is going to be the slope. What about the y-intercept? Well, the constant row gives us the y-intercept, because the y-intercept is a constant, and that number is given as 49.2804. If we then substitute those values into our equation, predicted y is equal to 49.2804 plus 0.5396x, where x is the student's pretest score and y hat is the student's predicted final score. Alternatively, you could save a little bit of time and effort by just writing it in contextual form to begin with. Predicted final score with the hat on top is equal to 49.2804 plus 0.5396 times the pretest score. I recommend that approach so you don't forget to include the variable names as the context. Just don't forget the hat for predicted. All right, so part A is very familiar. From things you've studied back in Unit 2 of the course. Let's move ahead. Part B says consider the information presented in the tables and your answer from Part A. So Part 1, determine the value of the predicted final score for students with a pretest score of 65. So you'll remember from Part A, we had this equation that we read off of the computer output. We want to determine the value of the predicted final score for students that have a pretest score of 65. So we're just going to substitute 65 in for the pretest score and get our final score predicted of 84.3544. Easy peasy. How about B2? Interpret S equals 4.2682 in the context of the problem. Where is 4.2682? It's way down here at the bottom. And our final score predicted of 84.3544. Easy peasy. How about B2? Interpret S equals 4.2682 in the context of the problem. Where is 4.2682? It's way down here at the bottom. So you may remember that that is some kind of standard deviation or standard error. It's actually the standard deviation of the residuals. S equals 4.2682. It's the standard deviation of the residuals from this regression, the linear regression of predicting final score from pretest score. Now, that doesn't interpret it, that just tells you what it is. The interpretation, when the regression line is used to predict final score, obviously from pretest score, the typical prediction error would be about 4.2682. It's telling you the size of a typical prediction error. I'm holding my hands like this because it's sort of a typical distance from the regression line that your points would tend to be in the scatter plot if we had it. So parts A and B are all things that you should have already been asked to do in your course. We're about to pivot into the more investigative aspect of the question. For any particular pretest score, 2 point estimates can be calculated from the given simple linear regression analysis. So you've heard of a point estimate that came up back in Unit 5. Point estimate 1 is an estimate of the mean final score among all students with a particular pretest score who complete the course. So we're focused on the average final score of all the students that have a particular pretest score. Point estimate number 2 is a prediction for the final score of one student with a particular pretest score who completes the course. Okay. So mean final score for all students with a particular score versus final score of one
I don't know
student.
how long I've been muted.
The values of both point estimates are equal to the predicted value of the least squares regression equation for the particular pretest score, such as the estimate from part B1 for a pretest score of 65. Although the values of the 2 point estimates are the same, the sampling variability is not the same. So you might recall in part B1, we calculated the predicted final score for a student who scored a 65 on the pretest as 84.3544. One of this discussion is that would also be the predicted
I
average
need like
final
a
score
big
of all the
picture
students
saying
who
that
earned a
like
65
I'm
on the
muted,
pretest
you
in this
know?
particular coding class. So you can think of it for predicting an individual's final score if they got a 65 on the pretest, or predicting the average final score of all the people who got 65. And here's the question. Which of the 2 point estimates has the larger sampling variability? That is, if you did this process over and over again, which of these two would vary more? The score of an individual person that had a score of 65, or the average score of a group of people who took the course pretest and post-test and had a score of 65? Which varies more, individual score or average score? I think you know the answer. It's just how do you explain it? So the larger sampling variability comes with point estimate 2. An individual student score is going to vary more given a particular pretest score than the average score of several people in the course. The sampling variability for point estimate number 1, that's the mean final score, reflects how much the value on the least squares regression line for a particular pretest score varies across random samples of 12 students. Because remember, we're trying to predict the mean final score for all those students, those 12 students, and the mean final score is the value on the regression line as well. For point estimate 2, it's larger because it reflects the student-to-student variation in final scores among all the students who got a 65, as well as the sampling variability for groups of people that got that. because it predicts the average for that group of people that scored 65, but individuals vary a lot around that. So it's pretty clear, I think, that individual scores vary more than averages in this scenario. All right, part D. The value calculated in part B1 is an estimate of the mean final score. All students with a pretest score of 65 who completed the course. And just as a refresher, you got 84.3544 is that prediction. If a list of the pretest scores and final scores for all students who completed the course is obtained, explain how this information can be used to investigate the sampling distribution of the estimated mean final score for all students with a pretest score of 65. All right, let's digest that. Focus on the mean final score for all students with a pretest score of 65. And we want to explain how we could use the information provided, the list of pretest and final scores, to investigate the sampling distribution of that estimated mean final score. So here's how we could do it. The sampling distribution of the estimated mean final scores for all students with a pretest score of 65 could be simulated using the following steps. First, select a random sample of, say, 12 students from the list of students who completed the course. And then, for that random sample, that scatter plot, calculate the equation of the least squares regression line using the data for the 12 students in the sample, and use that to predict the final score for a student with a pretest score of 65, which is the same as the prediction for the average final score with students that have a pretest score of 65. So that would be our predicted value of the mean final score. And we would do that over and over again. And
Oh, my chair's falling. Okay. Is it a predict? Oh my god. Okay.
what's not written down here is you can sort of picture making a graph of that and building up a distribution of these simulated predicted mean final scores for students who got a 65 on the pretest. So we do a random sample, get a regression line, get a slope, plug in the value to the equation again, and get a number for the average for all the people that got 65, like that prediction at 65, and continue to do that repeatedly. You know how to build a sampling distribution. This just might not have been expected as the final part of the question about regression and prediction. So that was a lot to take in, but what I wanted you to take in most is that the investigative task is by no means impossible. In fact, several parts of it are totally familiar. You definitely have those parts in hand. Even the other parts are scaffolded in such a way that you can do one part even if you've missed another part. So don't skip any parts. Don't give up just because you see a lot of text. Don't give up because you don't recognize what's being talked about. It's delivery. All the students are in the same spot as you are. Now, need more practice. We all need more practice because nobody's perfect yet, but you still have time before the exam. How might you get more practice? Well, let's direct you to AP Classroom first. In the review tab, you'll notice several really valuable resources. First, we have last year's 2023's AP Daily Practice Sessions, 8 sessions just like this that all feature different questions and are 15 minutes or less each. So that would be a quick way to practice more questions with handouts that you can download and try before you watch our solutions. If you want greater depth, you can go back to 2022 where we did AP Daily Review Sessions. Those were 45-minute sessions where we drilled really deep into each of the content areas of the course, as well as talking about specific exam tips. And likewise, we did ones in 2021 that were also about 45 minutes, deep content review, as well as strategies for success on the exam. That's a lot of valuable resources, all the practice questions that you should attempt before you watch us do them. That's the way you really get better at doing this. A couple of parting thoughts. First of all, you can do this. This exam is definitely something that's within your realm to score well on. What's well, depends on how much you've prepared now throughout the year and how confident you are going in. Hopefully these practice sessions have given you some more confidence, but they've also identified the areas where you might need to do a little extra work before you take the exam. Just keep in mind, you can do this. All it takes is a little bit more practice. And most importantly, I hope that you've gotten some value out of each of these sessions that you've taken part in. Thank you very much for the privilege of your time, and sincere best wishes for success on the AP Statistics exam.
Thank you. I mostly, I guess I did do this to learn, but then also it was nice because then it's extra credit, so it'll help boost my grade. And I think we are done. Ooh. No more AP statistics. No more AP statistics. We are free. Free. I don't have to do my Spanish final, which I'm probably not gonna do. See, we're cooking. All right. I'll I'm gonna see if she opened up AP Classroom. Unfortunately. All right. My computer should be fine. I can check it like during school in the morning, I guess. But let's see. Okay, enough with the voice box. Boom, ba-bum, ba-bum. Make it available. I want to see. Okay, whatever. Look, I love psychology. Ignore the really bad ones, but I love psychology. we ignore this one. What did I say? You're supposed to choose one. But that's okay, because look, on the final, I got a 13 out of 14.
Attack its weak point for massive damage. Attack its weak point for massive damage. Attack its weak point for massive damage. Giant enemy grab. Attack its weak point for massive damage. Attack its weak point for massive damage. Attack its weak point for massive damage. Giant enemy grab. Attack its weak point for massive damage. Attack its weak point for massive damage.
Okay.
Attack its weak point
This song's a little bit intense. Let's
Giant enemy.
Okay. We're done with stats. No, I got a notification. Okay, well, I think here's what I'm going to do. Since I'm done with this, I'm just going to play some games, then I'm going to go to my band concert. That's my plan. Yeah? What do you have to go? Get us together. Oh, yeah. Okay, so what we're gonna do now, because we're done, let's see. Oops. We are going to... Let's see if I can find it here. Yeah, there. And focus. We'll just say finished. Alright. Hold on. Okay, so if Monday's so Tuesday's 12th, Wednesday, Thursday, Friday, Saturday. Off and we're gonna play some crab champions. Try different weapons this time because all the achievements. Let's see which ones I didn't get yet. There's a lot of them. Okay, auto rifle. Let's see. Okay, auto rifle, grenade. Rifle, grenade, and let's try the katana for funsies. gotta be kidding me. Secret chest. Good to know where all these secret chests are. For funsies. Alright, let's see what do we get here. See how the start of every island. Alright. I'm gonna do, if Brock were here, he would say to do that one. I really need to increase the damage of this thing. I'm not used to this. Nice. Alright. Max health increased. Damage to nearby enemies. Shots do more damage for each shot you hit in a row without missing. Greed. Oh, I have to destroy the nests. Okay. Ooh. No. Why did you pop? This is infuriating. If you don't know what I'm talking about, the golden rocks you see, they give you. Maybe I was supposed to do it before, but they give you additional health, as in they like heal you and stuff. Let's do flawless. We get 2 chests. Is that flawless? It was. Alright, let's see what we get here. Shots deal, but orbit around the spawn point. What? Shots deal more damage. Let's do distant enemies. Shots deal more damage, clip size reduced. Shots deal more damage. Shots deal more damage. Each shot fired until stop firing. Okay. Those are aggressive grubs. Ooh. I got a text message. From who? Nice. Okay. Ooh. Alright. Shops are discounted. Let's do discounted prices because we're about to go to the shop. Alright, let's see. Plus crystals. Nah. What do we got here? Nearby enemies on impact. Arcanifies enemies. Let's do this one. It's just not on sale. I like that one. It will save money. Do the thing, because I have difficulty modifiers on, right? And so it spawns 2 elites. deal with more annoying one. There's that laser guy. Almost down, that one. Ooh, look at all that damage. Yeah, don't mind if I do. Oh, what? Why did I take all that damage? What the freak? Let's do heal. Okay, I'll look at my tits. Alright, let's see here. Sorry. Actually, we're gonna move this to gaming. You know why? Because we're gaming now. Yeah, there we go. But are replaced by legendary chests. Oh, of course, I'm enticed. You know, I love me a little bit of gambling. Okay, here's what we're gonna do. Nice. What's that? Oh, those are the shadows. Yeah, it's probably just a shader thing. Oh man. Yoink. Additional flat damage there. We'll do luck. Ooh, no. Okay. This is not a flawless run, I can tell you that. Okay. Chance to get one flawlessly clearing an island. Alright, that means from now on we have to be flawless. Last one, wasn't it? Oh, it was a fuse totem. Alright, so we should be on the lookout from now on. Cooldowns are also decreased. Shots do more damage, which spread is increased. Let's do melee and economy. I'm like 100% sure it is. Ooh. can leave them. No, you damaged me, and now I'm really angry. Goodness, I need more damage multipliers. Let's do critical. I hate you. What? Oh. Why were there two of you? What the freak? Okay, I kind of hate the auto rifle. Boom. Heck yeah. Alright. Let's do that. Shots bounce around. Damage. Abilities deal by moving random patterns. Let's do a economy. Okay, I need to remember that I have no buffs right now. Suppose I gotta do risky. Jerk. Yoink. Right. Gain crystals. Let's do gain crystals after clearing the dragon. We'll do random. Hey. Ooh. I do like loot. You've got to be kidding me. launcher crab. What? Okay, let's get this. Link. Alright. Let's do discounted prices and luck. But we're rich. Ooh, nice. Yeah, we'll force a bit, why not? Okay, let's see what we got here. Vampire, just do more damage. Just do right here. Alright, let's see what we got here. Arcs into damaging levels. Coils heavily increased. Dagger arc. Alright. This means they're going to be 4 bosses, just so you know. Lost like all my health just fighting this one crab. I'm not gonna say that I don't think I'm gonna win. Okay. Alright, one more, and then I think I do have to start getting ready for my events. Okay, so we're gonna gather them up in all one place, right? And then we're gonna do this. Yeah. Let's see here. I need more damage. Heal, rapidly regenerate. Go send it. You are not. No. Actually, it's early on. Whatever. Jerk. Why the two? Oh my god. Nice. Okay. We lost all our action? Come on. You know what they say. Can't lose. 3 times in a row. Gambler's fallacy. There, see? That should reload to a weapon. Ooh, this would be really helpful. Because I'm always doing that anyway, so I'll do random. A little too in myself. A little too cocky. Oh, I don't have a close YouTube chat here, actually. Hold on. Yeah, there we go. No, you are acknowledged. Bounty Hunter. Let's do that. 2 grenades. Last totem. Okay. See, it's literally, it's broken. Alright, let's see here. Do random. Bro. What is this? That's fine. That's nice. This would pair well. Let's see here. That's fine. It's pretty early. What can I give up? Alright. Yeah, why not? Yeah, look at that damage. Might not have to get a chance to show it off if I die. Okay, that was actually not that bad. Where's the crystals? I saw the big crystal. Or because it wasn't destroyed by me, I don't get it. Okay. That's a scam and I'm upset. Oh well. Get that key. The health chest. Let's see here. Let's do max health multiplier. Sure. Targeting shot. Get this. Okay, that's good. I do like that. And it's a relic. Crystals when damaging enemies. This is awesome. Yeah, for free. Ugh. Big shots. Increased melee damage because that was annoying. Alright. So if I just keep jumping around, then I don't need to reload. Okay. Shots deal more damage, melee damage. This is good because I'll keep reloading. Okay. Sweet. Melee cooldowns reduced. Sweet. Stream mode. Let's do stream mode. Yeah. big chest. Alright, healing more effective. Taking... Yes, that would be nice. Let's do the gauntlet. First, we're gonna explore my environment. Like, good stuff like that. There's a secret chest. Spread heavily reduced. Why not? Alright, and we begin. And I do know that there's a creek. This is like one place where the randomizer fails because we're indoors. Speedy Gonzalez. Okay, so stay away. One more. Landmine rain. Okay, so we'll do the first biome. Don't need that. Nice. Silver lining. Damage increased each time you take. Oh no. Let's see, tasty damage. It's up for each island, but that's still good. Let's do this and then I have to go. This is good. This is, oh. This is the equivalent of playing Pyro in TF2. Boom. Okie dokie. Ooh. Did I get the crystal one? I did. Okay, I believe it's saved. Let's see. I'm just double checking. It did. Okay. Okie dokie. Well, thanks for tuning in to this 7-hour stats stream with me, where most of it was spent on stats. Oh, now we're catching up. Okay. I never ended the stream, didn't I? I got distracted. Okay, well, anyways, thanks for coming in.